There we go. So let's see. So we have two main things. Like I want to talk about some of the multidimensional acquisition parts here. So Z-stack tiles time series, and then area scan, right? Like imaging on the area scan. I'll go over this part first, um, which is so when you're in that acquisition tab, right? Like of course, um, set up, setting up all your parameters, you optimize your laser power, pixel size, all of that. Now you want to take um, some actual data, right? So like Z-stacks or time lapse, all of that. So lives here at the top left. So it's basically a matter of if you want to add a Z-stack, you check that box. You'll see this little stack icon showing up here, and you get this menu down here showing the stacks. And that applies to any of these, whether add time series, you see these little ghosts showing up on the timeline. If I add tiles, you see these little tile shapes right here, and all of these things can be combined. I don't recommend starting straight with a Z stack tile time series, but all of those things can be combined. I always recommend like starting at one and then building it up, right? Like, does my Z stack look good? Okay, now we can do multiple Z stacks over time or multiple positions with Z stacks. Um, but all of that is here in the top left. It's just a matter of activating the right menus. I mean, Z-stack fairly straightforward, right? If we go, what color am I on? Red. Let's see if we have anything in focus. If we have anything. There we go. Oh, yeah, that's probably better. So here, if we're doing a stack, um, there's really two main strategies. Um, Really straightforward. You can do, especially if you're just doing a Z stack, you can set a first and a last. You go top and bottom. Doesn't actually matter really which direction you're going in. It'll know, right? If you set your last first and then your first, it knows relatively in what position you land. And you see here, right? Like you see your end slices, first and last, and your center. Double clicking on the center will just make it jump right over there. Similar to the XY resolution, there's also Z-stack um, resolution, right? Like if we have more slices, we can catch more 3D information. So that button right here, I mean, the full explanation shows up when you hover over it. Nyquist sampling is used for optimal step size setup, etc. So it really just calculates based on the um, objective that we're using and the wavelength that we're using, what is the optimal step size to use here to sample all the information in 3D. Again, doesn't mean that you can't do, say, like a bigger step size, right? Like you can always adjust this, right? Say if I want a larger step size, totally fine. But this will make sure that you get like the highest possible Z resolution on that objective with that particular wavelength. Of course, if you do smaller steps, just like in the X and Y, you are oversampling. So then you're not gaining as much from getting those extra slices. You won't really see more than the objective can physically resolve. So you're hitting the limits of physics in that case. So it's just good to know. If you leave this highlighted and you make any adjustments with first last, it'll automatically recalculate. But first last, this is probably most typically what people do, but there's also the center mode right here. If you go center mode, basically that lets you set one value. Right now I'm already sitting in the center, so when I hit that center button, it just takes whatever number, whatever the focal value was in that center here, and then it'll capture whatever range you put over there. So say I put 60 micron here. Now it adjusts to collect 60 microns around that center. So 30 above, 30 below. Very straightforward. It automatically again calculates how many slices you would need with that optimal button highlighted, right? If this is not highlighted, that's going to ignore that. Optimum is just going to look at like the number of slices at the interval that you tell it to do. So generally, I recommend having this on just so that you get all the information, unless you're just trying to get a rough idea of the structure, right? Getting a rough idea of the 3D, you don't need the finest details. In Z, you can always manually adjust the interval there. Those are really the main settings here. One thing to keep in mind, if you use that center mode is really important once you start combining it with other functionality. So if you, for example, take a larger tile and then have a couple positions where you want to do a Z stack, you want to use center mode so that for all those positions, it uses that individual position as the center. So it can jump to multiple positions. The Z can be different, but it'll use that center mode and it will use the Z for that particular position. And I can show what that looks like when we add tiling. So once you start building experiments into something bigger, right, using multiple modalities, it's important to have that center mode. You can also
enter center.
So here,
I just realized there's two center.
So this is one that shows you the menu. And then if you hit this button, that'll set the center. So say I go somewhere else. So let's scan. I'm going to just hit control and roll down. You can see where in the stack we're moving now. And say I want the center to actually be here. I just hit center here. You see now we're centered again, but we're centered around that spot that we moved to. So now this number also changes, right? But you have to hit, so you have to tell it what you want the center to be, right? And if you only have a Z stack, this is what it's going to read out at the center. If you have Z stacks and tiles, the tile information will override whatever it says here. Because then in tiles, you have multiple locations, right? Like if we have, say, a 3x3 tile, the center of that tile where you set that Z value will be the center of your Z stack. So it will take a Z stack and a tile, but the center will be defined under that tile menu. Same with positions. That is also under the tile menu. If you set multiple positions, that will be the position Z value will be the center of your stack. This lets you set different heights for different Z stacks throughout a larger sample, right? If you go all the way to the other side of your slide, you don't want the center to be the exact same number. That makes sense. So only other things here in this menu that take into account. So there's two checkboxes here. I'll leave this off. So there's optimized sectioning and step. This is mostly for if you really want to synchronize every individual slice. Remember, if we were talking about pinhole size and how the size of the pinhole can be different for different tracks. Here you can see what the pinhole size like equates to when it comes to the actual slice that it's taking. So if you want the optical section to be exactly the same thickness, this is where you can synchronize that. That's why that match pinhole button here is. So what it basically does is it sets an optimal pinhole for all of the tracks. You could ignore it and just have like your pinhole set in that channel to the node, basically optimize it for every individual track. Starting out, I'd say that's a good point to begin because you would have like the best possible settings per individual track. But keep in mind that there will be, if you have a very long wavelength on one side, very short wavelength on the other, different pinhole sizes will get you slightly different section thickness. So you won't notice it as much on like the low res objective, but the higher magnification, those slices, if they're like slightly different thickness, like you might, like your resolution for one slice is going to be slightly different than the other. So this is here where you can synchronize that by hitting that match pinhole. Generally, if you're in line scanning mode, this is what you want to use. Like you match the pinhole for all of them and sort of like optimize it for all the different slices. More commonly, or something people use a lot more in this menu is this auto Z brightness correction. So what it does there is, especially for larger samples, so very thick samples where you see the signal dropping off when you're going deeper in, this lets you adjust the laser power and the gain for different slices within the stack. So while it's scanning, right, you can see here the objective is oriented here. Generally, your signal will be brighter at the bottom of the stack versus deeper in. So you can tell the microscope, okay, I want my laser power at the start to be this number, and then later deeper in the stack, I want it to be this number. So all you have to do for that, and we'll just do it with the red channel, is to keep it simple. And I'll pull this one here out actually there, so we can see both things here. So right now you see that 0.4% and 670 volts gain. Let's move to the start. Or actually, we'll go the other way in this case. It's brightest here. But basically, if we, looks like the Z stack, oh, we moved that center, that's why. So let's do the center a little where it's brighter. Here. So if we now want to set individual like laser powers for different depths, basically move to, say, in this case, the start. You can hit this add update button. So now at this particular Z slice, you can see it's not quite the first, it's just like a little bit into the stack. It records 0.4% and 670 volts. If we then go like somewhere further into the sample, further away. Of course, this sample is really bright, but most typical samples, especially fluorophores, are weaker than something that autofluorescence like crazy like this. It's gonna fall off and get weaker. So say we want a higher laser power here. Let's say in this case, let's see what 0.7 looks like. So we set higher laser power or gain. You can modify whichever setting here, and then you hit add update. Now it has 2 points, both with their own laser power set. So now you can actually say, you see here like how it says extrapolate. This is important for adjusting it throughout the stack, even if you're beyond the point that you go, right? Like we want to extrapolate that intensity value. You don't want it to just be different in this section where we put the slices. And then I always like to click enable test. So what that does is it lets us move through and see how it's now changing the laser power to the numbers that we did. So you can see the effect of the laser powers that you put in, and it should even, like if we go beyond, right, even beyond the stack that we set, because we hit extrapolate, it'll keep increasing that laser power. So you can see where it lands. So this is good for testing. If you uncheck that box, enable test, it'll just leave it wherever that laser power is sitting right now. I mean, that's pretty intuitive. It's basically just showing you what you put in versus what it will look like when you hit the stack, when you check that box. So those are the two I want to check. Spline interpolation is more for if you have a lot of different, say you have a very long Z stack and you actually want the laser power to, like you said, multiple points for like more elaborate interpolations. Most situations you wouldn't really use that. Most of the time you'll have like two values that you want to set up and have that run through a stack where it's like high laser power here, low laser power there. You could even have a situation where there's just like really bright signal in a certain spot in the stack and you don't want the laser power to go up that much. The only thing you have to keep in mind here is when you're changing laser power throughout a stack, if you're doing any quantifications, right, like this is not going to be linear, right? Like the laser powers are different throughout your images. So you do want to make sure if you're going to do anything quantitative, you're going to have to either do that with a separate experiment or some other, it depends on if you're looking really at those intensities. If it's just structure, doesn't really matter. Either if you're trying to get an idea where what things look like in 3D, you just want to get a little more signal from the deeper tissue, then that should be totally fine. But yeah, do keep that in mind if you're later down the line trying to do any quantifications on that. If it's been treated with this, you want to make sure you're not really drawing strong conclusions on the intensity itself, because that's going to be highly variable. But yeah, that's most of the things in the Z stack menu.
Can you specify different first and last positions for different positions?
So in a typical experiment, you would just set a center, right? And you would have the same range. You're saying like if you want a Z stack that is say like 60 micron here and then somewhere else in the sample like 30 microns, right? Yeah.
Or maybe the same 60, but lower.
Okay, so same 60 and lower, that's straightforward. Like there, you just put different positions with a different center, right? Like the center, so maybe we just go to the tile section so I can show what that looks like. So if I check that tiles box, you get this little menu right here. It says tiles, it says show viewer. We're just gonna hit that button right here. This is kind of our map of the area. I mean, of course, now there's no image there, so it's completely gray. But this is a representation of where we are on the sample, and this is where you could set those different positions and tiles. So that's all that all lives here, and we know our sample is circular. So let's take a look actually. Let's change this setting actually. So you can see here at the bottom it says tiles, new tab. That means that when I hit live, it shows up in a new tab. I don't like that setting. I honestly usually go to separate container or tiles view. Tiles view will just show it inside the tiles view when I go live. Right, see there we see our sample, so we can actually like drag this around and like figure out like, okay, this is kind of the middle. And then if I want to draw a tile region, I will just do that right here. This should be about where my sample is. Or separate container. Separate container will have your live view right here and your map right there. You want to give yourself some more space. There's always like little arrows here that push the menu to the side, so it gives you a little more room to work with. And let's see, looks pretty close actually. So this you can use both to make a map, make like an overview of your sample, and then also set these different positions as well, or tiles. So if you look here, this top part of it is all for setting up different types of tile regions. This bottom is setting up for different positions. The top here, when we have this one, this tile region by drawing selected, lets us draw. So right now what I just did is I just clicked circle and draw a circular shape for tiling.
Can we max the workspace?
Oh yeah, let's bring that up a bit. Oh, that actually, well, it'll make the words bigger, but this view smaller. I mean, we could make this bigger, but then this, yeah, it depends, right? You can play around with it a bit, but generally, I mean, you can zoom here as well. So if you use the mouse wheel, this will just zoom in and out of the map. I think what we should do too is just like create a quick map of where we are here. If I'm gonna be on like 10x or so, and I want to get like a quick idea of this area, let's not do the Z stack because that would take a bunch of time. Set this to fast. I don't need the best resolution here. I just want to get an overview. Let's do bidirectional. Let's not do averaging. You see now it's like 300 milliseconds to take one of these tiles. So that should be really quick. When I drew the tile, and this is important. So if we go to the tiles menu, tile region, when I drew it, it used the current focus value as the Z value for that tile. That means that wherever we are right now in Z is where it's going to take this tile. You can adjust this too, like you could go live, go to a different plane and say, I mean, this looks good right now, but say I wanted to do it somewhere else in Z, you can move the focus and then right click this tile region and then set current Z for selected tile region. That'll adjust the Z plane for the entire tile region. And we'll pick the tile right there. Right now, since I want to kind of make a map here, I'm just going to hit preview. And we don't have to really preview images because there's nothing there. And then I'm just going to use all my experiment settings that I have here. So just this red channel to do like a quick scan of this area. And since we set it to like relatively low resolution, it's now just creating this area as a tile. And I'm going to get rid of this tile region. Now we can use this as a map. So if I double click around here, it will send the microscope to whatever location here. And to get back to your question, right, on the Z stacks, right, in the different positions, now if I have this map and I go to positions, so positions also lives under that tile section. I'm just going to open positions here. You see nothing in that list right now. But if you want to add positions, you can click here, say add position. It'll add one right where we are. You can also move to position, hit F10, it'll also add a position right where we are. You can see every position has an X, Y, and a Z. So if you're taking the Z stacks at different heights, you want to make sure you set the Z here to wherever you want the center of your stack. If you don't know where the center is, say you know your tissue, right? If you have an idea of like, okay, my tissue is here, but when I'm moving through, it's not always obvious. Like I should set my center here. A good trick for that is basically using that first last. Remember, we have that first last here. So you go live, then it's pretty easy to find the top and the bottom. Right, you go to top and bottom. Doesn't really matter. You hit center here. So now we have a center value. Wherever this focus is a good center value. And then we set center here, or we set the position here. Like if I press F10 right now, it'll add the position in this particular center. Or I say for position 2, I want the current Z to be the center. So that way you know you have the center right where you want it to be for your Z stack.
Why, when you do that, why the C position is not updated? The values.
Oh, I think we're in a very similar value. Let's see, because you see it jumped from like 1540.2 to 5040. You see the difference between these two? It went from 5040.2 to 5040.1. I mean, I should move it a little more so it's a little more clear. So now I'm just gonna right click. Oh, right click here, set currency. See, 1524. Yeah, we just happened to move. Not that like our center was already very well centered, but it's because the sample is pretty straightforward to find the brightest slice. But if you have something bigger, it can be harder to find that center. But this also will help you, especially if you do that first last, right? Gives you an idea of like, oh, how large should the stack be, right? Like if I have about 45 microns, that should capture most of what I want to see. The only thing you can't directly do in this menu is if you want, say I want this stack here to be, yeah, like 45 micron, but I want the other one to be like 30 micron. Because that number here is just going to be, there's only one input value. If we want to change that, we have something called Experiment Designer that lets you do like multimodal experiments. If you've ever done any like coding, programming type loops, right? Like works very similar where you can actually add acquisition blocks that you can fully customize and modify and then have executed in sequence and then loop through if you wanted to. So in this case, I would say just duplicate this experiment. So right now in the experiment designer, right, like you see here, 2 experiments. They're identical experiments. They're both this Z stack, in this case 45 micron with these 2 locations. But then in one experiment, I would say, no, I don't want it to be this about 45 microns. Let's make this like 30 or so. And then now we'll probably have one position. It all depends on the positions here. In this case, we'll have one position where we do the short Z stack and the other one will do the long Z stack. So in this case, I would remove P1 here. And in the other experiment, I would remove P2 like this. So now when you hit start experiment, what it'll do is it'll take, we'll go to this experiment first. It'll take that Z stack, like 45 microns, then jump to the next one and it'll do that next position for 30 microns. I would always set all your parameters first, like even set multiple positions in one experiment and then just duplicate. Then you don't have to set up settings for every one of these experimental blocks. Because that otherwise, yeah, this is like the shortest way. Because the only thing you really have to modify here is the range of the stack, right? But you could do technically everything here. Like Experiment Designer is really there as a tool to make like super multimodal experiments. Say you want to take in the same start experiment, right? In the same, you just want to hit this button and then walk away. Say you want one area where you want to do 3 colors and another area where you want 2 colors. One, you want a TPMT overlay. You can all change all those parameters. Say if I want for that second position here in that second block, if I want to add more colors like the green and the 647, I can do that. So now you can see first experiment, I'll just get the red. next experiment, I'll get pre-colored. So anything you can change in an experiment, you could modify here. So experiment designer is really there to make the more, I'd say like somewhat less standard, but still very useful workflows possible so that you don't have to set up a Z stack, take it, then come back, do another Z stack and change the range. Like you can set it all up in one go, hit start experiment, and then just like let it do it all on its own. Does that make sense? Like that's really the way to set up like multimodal Z stacks in this way.
What is the difference? You also have automation, so that's also working.
Yeah, automation is more that's more with code. So if there's like an experiment that is not covered by the software,
Oh.
automation will have to like write macros. Like we can control like that's like another step.
Oh.
Right, where if we wanted to also do like some like have external software do parts of the workflow and then come back. Most of the time, most typical applications not really something you would use, but this checkbox is always there. I'd say just looking at these like this bottom section here. I mean, auto immersion obviously
Yeah.
something we have here. Bleaching, that's for in like FRAP experiments. That's something that gets used relatively often. Image export is more for, yeah, like if you're doing a lot of experiments in this, want to auto export certain settings. And direct processing, that one is also something we could use here. Of course, that doesn't actually work with the experiment designer, so we'll disclose that one actually. But this is for streaming data to the other PC. So you already have, like if you just want to save something on the other PC, like we can see it showing up here. Swap, right? There is a network drive. It's called swap. You could change that name if you wanted to. Like this is just like a Zeiss networking convention. But you'll see it here like data, a data folder that you can open on the other computer as well. So this is literally a folder that is shared on the other PC. So you could always move files. I mean, that's just a network connection. That's nothing, has nothing really to do with Zen. Direct processing though, it lets you stream data while you're acquiring and then processes the data while it is being acquired. So you don't have to wait until data is done and then run the processing step. And that's mostly aimed for ARIScan processing. Because ARIScan data, because it comes in from multiple detector elements, it has to be processed into one final image. That's the one that's really handy to stream to the other computer, let the other computer do the processing while you're acquiring, and then you get the data very quickly once the experiment is done, instead of you having to manually run the processing step. So that's really the main thing here. But if you're just moving data, it's also possible you can just drop it in that folder. I would recommend in this folder, like I was like testing this if it worked, but you can make your own folders in here for like storing data. I think the other computer also has a lot more space than this acquisition PC. You generally want to avoid, especially this PC, to get too full with a lot of data because then it's going to slow down. It's going to affect the operation of the microscope itself, where the other computer is separate. Also, if people want to analyze their data, they could just go there and analyze the data versus, having to actually take time on the microscope while someone else is acquiring. The only thing for the direct processing, and we'll go over that when we do ARIScan because that's what it's mainly used for. But what's important for the direct processing to work is that the other computer has to be on, and then Zen has to be open. Because they have to be able to talk, the two Zen, right? Zen has to do processing on the other PC. They have to be able to talk to each other. But we'll get to that when we do the actual direct processing. And activate experiment designer, because at this point, let's look at, so we should look at tiles a little bit more, because there's just a lot in this window that you can do. So I already showed a little bit of how you generate a tile region, right? Like you can just draw them under here, square, circle, freehand. So if there's like a particular shape, right, you could either just draw something here. You can also say, a little more the old-fashioned way, just add a 3x3 right where you are, or a 4x4, 2x2, whatever number you put up here. If I hit add tile region, it'll just add that where we are. You can also see that the tiles, right, they're based on current objective and then current overlap that is set. You see here, there's like double lines here. Those are the parts of the tiles that overlap. Yeah, you can check that overlap under the tiles menu under options. Default overlap is 10%. You can play around with that. Generally on a confocal scan field is going to be pretty tight. It's not like with a camera where you'll see more shifts between the tiles and you'll need more stitching. I would still stitch the data, but I wouldn't expect there to be like large shifts. If you do see large shifts between the tiles, usually it needs like a scanning calibration. But that's good to know. So what here, that yellow area is really our tile area. So it's going to calculate the tiles based on that yellow area that we've indicated. Right now we set 3x3, so our 3x3 fields of view is going to exactly match that area that we're trying to capture here. But if I'm drawing, if I'm doing like a freehand here, say, let's grab a circle. Right now it sees that one tile cannot cover the circle, so it's actually generating 4 tiles to make sure that it overlaps fully with that yellow circle area. But you can also see that it'll grab a lot of area that you're not as interested in. So here you can play a little bit with either the zoom or adjusting the tile area depending on what you're trying to see if you can like maximize your sample versus area scan. Similar to when you're doing a single field of view and you're just playing with the zoom and adjusting the frame to what is scanned. So that's what you can do here. There's another mode, this third mode here. So the top one is for 3x3, 2x2, all that stuff. This is for freehand drawing. That third one here uses actually like boundaries that you set. So if I now go live and I move to the edge of one of these areas, of course, we know already because I scanned this map, we know already edges. But if you are in the dark, like you don't actually see anything here, you just started on your sample, this will let you actually set a tile region based on the boundary. So you just set a marker here. You see like the little cross that shows up there. And you set a marker here. You can see it starts drawing based on where we set our edges. See, now it makes this circle because we indicated we wanted a circular shape and we say the borders are right there. So it'll adjust it depending on where we say in the live stream, like, okay, one of my borders is right there. So that's another way to draw the tile regions. I'd say everyone kind of has their preferences there. I tend to do this thing where on the 10X, I'd like to take an overview, use this as a map. Of course, this map will stay accurate as long as you don't take off the sample, right? If I now grab the slide and then put it back, this is going to be somewhat shifted. That'll always happen. But if I from here, like click on say like the 40X, don't touch the slide, and we can use this map now. Let's see, we'll just jump to the 40X. It'll actually ask, because this is the auto immersion objective, it'll say, oh, do you want to add some auto immersion? You can say continue and create immersion, or if you're like, oh, I actually want to click the 25X, you can always make it go back. Same with that 25, it'll actually say, oh, you're changing immersion. I think we should double check that actually. If there's something called an oil stop or an immersion stop, it'll just always give a warning if you're switching between immersions. Which in your case, when especially between these two objectives, you don't want to go from 25 on oil to your 40X water. The 10X I would be less worried because there's long working distance. If it was a 20X, that's a little more of a one of the things we run into the field a lot is people going to oil and then back to the 20, and the 20 has a short working distance and then dips in oil. And then everyone's like, why does my image look blurry? But you won't have that here so much. But between these two objectives, I think it's always good to keep an eye on that. So let me check in your. It's multi-immersion.
Oh.
Multi-immersion. So right now, I think it's set to oil. Yeah. So you can see how if you hover over it, it'll say oil, but that's mostly something in the configuration file. It doesn't mean that if you put water on it right now, it won't work. It just means that the correction color is set to oil.
Oh.
And if you look at the, you want it on water?
Yeah.
Okay, so we should look at that then, so look at the correction color. We can adjust that for just setting it on the water setting. I mean, will people use, because people will do some oil imaging, I assume, or is it,
25.
no one will do it on the 25?
I mean, most of the time, we're gonna be mounting in water.
Okay,
Like, the samples are gonna be mounted in water,
Yeah.
so like, I guess it's possible they could use the Emerson stuff. So that's like water, to rinse of the water correction. So I don't, mostly water.
okay, yeah, then we should sort of set it to water. The other thing is, you see that now in the software, it shows oil. So this is not in Zen, it's like a hardware configuration file. We should set it on water there as well. Otherwise, it'll just keep saying oil.
Right.
And I think that's gonna be confusing.
Confusing,
Yeah.
Okay.
So we'll do that. Let me write that down too, so. Because we'll do that at the end, like you have to close out of the software and then make that modification. Because any hardware configuration thing that you adjust, you don't want to do that while the software is on, because it'll basically like get an error, or it'll say like it doesn't see the component as as we configured it.
But if you said 25 is, but the 25 won't have the auto immersion, it's only 40 have the auto.
No, the 40 has the auto immersion. Yeah,
Right, the 25 don't have.
25 doesn't have it. Yeah,
Okay.
you could technically. I don't think we have.
What
You
kind
could switch it over. I mean, it's basically so it's like a little belt that sits around the objective.
All right, yeah.
So you have to uncouple it. But you also have to tell the software like, oh, now it's set up on here, because otherwise it won't show you these. You see how these buttons were grayed out. I'm just gonna say back here. So you see how these buttons are grayed out? It's because it knows it's not on the objective with the auto immersion, so it won't let you like just shoot a bunch of water onto the microscope, which makes sense. It's all it's all making sure it's not doesn't do anything what it shouldn't be doing. But when you switch it, yeah, it has to be programmed in the hardware as well. I mean, I guess it depends also like which objective do you expect to use more for like something where you would need the auto immersion. The 40. Yeah. Because auto immersion is really, because in the end, you can just add water, right? Like that's, and right, like if you're just throwing on something on there, like the auto immersion, that's not like fully required. It's more for like longer time lapse, right? Where you expect the water to evaporate. You don't want to come back in the middle of the night to add more water or realize that your experiment is suddenly like out of focus. So that's really the main point. So I think then we should leave that on the 40, but then we'll change the correction color and change it in the hardware configuration. So we make sure that that matches. But if someone is gonna switch to oil, so you could leave this on the water setting, but you will have to turn the color when you switch to the oil. I think we
that
have.
would be incredibly rare.
Yeah, okay, that's good. That's good. That's better than people constantly switching, because then it's gonna happen where someone's gonna image something on the oil setting with water, and then they're like, it doesn't look as good as it looked before. Yep. Yeah, so we'll set it to water and we'll program it to water. I think that's the best solution
Like,
here.
because we're usually imaging roots
Mhm.
live, roots are full of water
Yeah.
anyway. So they're full of water, you mount them in water.
Yeah.
And everything's water. So there are a few cases where, we might have fixed samples or something, but even then, we usually mount them in water.
Yeah.
Or in an aqueous.
They're in some aqueous media, right? Right. Yeah. So we should optimize and set anything on the water setting. That's good. That's good to know. So we'll make sure we adjust that.
25 has to be used with water, or you can just use this.
No, it's water.
Well, yeah, this immersion base. Yeah. So
Okay.
I mean, so it has a color on there that can be, it can be set to different immersion media, right? Like it goes all the way up to oil and then down to water. So it can also be a little in between. This is why the Microsoft, like it comes with So when anyone orders one of these multi-immersion injectors, it comes with the oil and then glycerin, which glycerin is like a little like in between immersion. So only if you're like if you have some kind of structure where it isn't as aqueous, maybe it's something in a gel. That's where I see people using like they play with the color to because you never know like what the exact consistency of the sample is. There can be variability. So people will play with the color to see where they get the best signal quality. But if you're mostly doing water, I would just leave it on water. And just make sure if someone is like making adjustments to that color, just to make sure that when they're done, put it back on water because it's going to confuse the next person. We see that happen a bunch. So the other thing, so we walked through like setting up tiles, doing positions. I'd say again, there's 5 ways to set positions, right? Like I usually use that F10 key. That's just like really quick. I see this light. This is where I want it to be. I just hit F10. It'll set the X, Y, Z. But you can also say add position, or if you have one of these maps right here, you can also hit this little plus icon and then just click. That's if you have a large area and you don't want to go through everything manually. You just like click at on interesting spots. But I'd say most of the time people will be in live trying to find a position that they want to image and then hit the F10 or that add position button right here. That's the most typical thing to do. So that's tiles and positions. But then here, one thing that especially if you come from 880 or 710 or any of the older models, the newer thing here in the tiles is that there's also a focus surface and support points that you can set up. So this comes mostly into play for tile sections. So I'll draw one here so we have some example to work with. So the focus surface and support points, really what that does is over a larger region, right? Like no sample is perfectly flat. There's always going to be like some unevenness. This lets you adjust the focus throughout a tile. So if this takes a tile right now, this tile region right here, it's just going to have this one Z value, right? So every tile is going to be in the same focus. However, if your sample moves up, moves down, especially if you're looking at like root tissue that like goes in like some kind of direction, this lets you adjust it throughout the tile. So you can say, oh, I see everything moving up this way. You add some support points that let the tile move the focus in that direction. So to do that, you scroll down here, you see focus surface and support points. Make sure that tile region is highlighted. And then you could either add individual support points. So you could either click in a spot and say add a single support point at that particular location, or if you have, especially with like say like a 2x2 or a 3x3, you can say in that tile region, oh, add 2x2 support points. In this case, well, it'll overwrite the one that I already have. I mean, that's fine. So now it'll do for the circle, it puts 4 points here at the edges. This lets you adjust for every one of these individual points, individual Z positions. So you can go live, and we'll do that now. Actually, we'll go live and we'll hit verify here. I'll minimize some of this stuff because otherwise it'll get kind of crowded. So if we look at this menu right here, you see the 4 support points and all of their own Z values. If we then go live, scan. Oh, what do we do? Oh, see, that's one way to show.
Oh.
Remember our arm, right? This has
Don't worry.
the check. Yeah, we're shooting lasers in the air, but you can see that blocks us from scanning, right? So that's exactly what that does. So that's what it's supposed to do, which is good. So now let's see. Now we should get something. There we go. So here, this is just our live screen. We see that support point is right there. You have this button that says move to current point. It'll jump to that particular support point. This is our current focus, but we can move this around. Again, this sample is not super uneven, but we can say, okay, this is where I really like my focus. You can hit set Z and move to next. So then you see this green check mark, and it set a Z value for that support point. And you can do the exact same. You can move through the focus, trying to find like your optimal focal point. Set C, move to next, etc., etc. This is actually one case where you could, if you have a giant tile section, this is something where you could use that autofocus. Like you could say, oh, let's try and have the autofocus find the Z planes if you don't want to walk through all of them. But again, that has that caveat where if it jumps through, if the brightest signal is somewhere where you don't want to be, you want to set those manually, right? So this is where you see under that drop down, that's where the autofocus here shows up. You also see definite focus. You could use definite focus if you know that your sample is always the same distance from the cover slip. So again, I'd say with a plant root, not as likely. Like if you have something really flat that's squished to the cover slip, maybe, but most cases I would honestly just move through here and then look at the focus myself. And then set C, move to next, and then we'll set a Z here. And now we have all the support points set. They all have like slightly different Z values. So that means that when we're now taking this tile, it will actually use that information to like adjust the Z plane throughout taking that tile. And this also works in combination with the Z stack. So if we're taking a Z stack and we're using that center mode, right, it uses this tile as the center for the Z stack. It's going to take, again, if it's 30 microns, it's going to take 15 micron above, 15 micron below. And then it'll do that for all of these areas, but then it'll adjust that center depending on where these support points are. The only thing you want to keep in mind here is there's this little drop down under here. It says interpolation degree, so that's how it decides the focus in between the support points. You want to make sure this matches to the amount of points that you have. In this case, we have 4 or at least 4. So we want to pick this one, at least 4 support points. This can simulate a tilted plane. You can imagine if you have like a tilted plane, as long as you have 4 points, you can simulate that in space. So that's what it can now use to interpolate and like calculate where the focus needs to go. Once you have more support points, so at least 9, and next iteration or next tier is going to be 15, then 22. It has ways to calculate more like intricate support maps. So it's called parabolic saddle surface. So I always compare it to like a Pringle chip, right? Like it can calculate more advanced like surfaces depending on the amount of points. But you need at least, in this case, at least 9 points to calculate a surface like that. With 4 points, you cannot see like the waviness of a structure. So you always want to make sure this matches to the amount of points that you have set on your sample. That's really the key. That's really the key there. So that all lives under that focus surface and support points, and that's really essential for like your larger tiles. If it's just individual positions, of course, doesn't really matter. But yeah.
One question, like, because for the old one, you don't have the flexibility. So this one, I can see when you draw the area you want, so they automatically calculate you need like, for example, they need a tile, a 9,
Yeah.
tile. But before it's like I have to kind of like, oh, maybe I need a stick. I have to set up myself and then see if how many. So this is how they calculate it based on the resolution or something? How they
So
calculate
this is mostly field of view. So if you look here, you see the red area. It's calculated based on, so we're on the 10x.
Right.
And then so it looks at the objective and it looks at our current zoom. So right now we're on the 10x at 1x zoom. That means that it can calculate, oh, that's this amount of microns, right? So it can say, okay, this is the area that one field of view should cover. But then it also knows, okay, we want a 10% overlap. So that's why you see these lines here. Those are the areas of overlap between the different tiles. So all of those things go into the calculation of what do we need to cover this area. You'll see if I do, say, a 2x zoom, see now all my tiles, like they
Right,
change.
yeah.
You'll notice that, see, we still get a square pattern even though we have a circle, because obviously we can't like really scan in a circular pattern. It just works off of the fields of view that we have. So it looks at that, okay, that's square. How can I fit this shape into these squares,
But the
right?
resolution also, when you do these 2 times, so the resolution of each tile is higher than when you said as
No.
one. No.
So resolution, like in the end, resolution is
Okay,
only
same.
dependent on your frame size. Yeah.
Okay,
So you can say confocal resolution, right? See, it doesn't change anything on the tile.
right, okay.
It just means that every individual tile has more pixels, right? So if I hit confocal here, right, we have now 930 by 930 for each individual
Right.
tile.
So when you put the whole image together, actually the resolution is higher than 1x, because for each tile you have more pixels.
Oh, you mean totally, well,
Right.
so your total image
Right.
will have more pixels, but the
Right.
actual physical resolution, so what you can resolve,
Uh-huh.
will remain the same.
Oh.
Because each individual spot, right? Because the resolution is really determined by how much, like if I have 2 pixels next to each other, can these 2 pixels like distinguish, like a structure, right? Like how fine is that on a, say, like a 10x? There's a point where 2 pixels next to each other are not going to see any difference because we're hitting the, like, literally the limit of physics, being able to get that light through a lens and then seeing 2 different spots. So really the resolution doesn't really tie to any of the tiling. It's really how many, like in one field of view, how many pixels can we resolve with this objective at this wavelength. So this is why this confocal button is nice, because when you hit that confocal button, it automatically calculates, like, this is the maximum amount of pixels I can resolve. So resolution wise, this is my peak on this objective in this particular mode with this particular laser wavelength. You'll see that when we get the area scan, and we'll do that next. This sampling will actually be 2x. It's because area scan is like super resolution detector. It actually has a double the amount of pixels compared to the confocal mode. So you'll have a lot more pixels, but that's because the area scan can resolve more detail. So it'll be a jump up in the pixel number. But in the end, the rules are the same. Like, this does not change anything on the tiling end. It does change when we change the zoom. The zoom really, it only makes the scan area smaller, doesn't really change
Oh, I
anything
see.
on the
Right.
resolution.
Well, the bigger area may
Yeah.
go through. Okay.
Yeah, like a bigger area will give you more, you'll eventually, if you grab a bigger area, you'll get more pixels. But the detail that the pixel resolve is going to be the same. Yeah. I mean, that's a good question, because I think it's often something people run into is like, oh, I just zoom in more. But that doesn't work like that, right? Like there's a physical, like physics will at some point stop you from seeing more with that lens at that wavelength. So that's really the key. The reason we want to zoom though, like, zooming can be really practical. Maybe not for like on tiling, I'm not going to zoom as much because I'm trying to grab a larger area. I'm not going to add more tiles for me to scan because it's going to take more time. But if you have something really small, like just say I only care about like this circle right here. If you then zoom in on just that circle, it means that you can maximize the amount of pixels in that circle and still not scan for very long. Like if I'm grabbing a larger area, it's going to take way longer to scan that area. And then say, if it's taking too long, I'm going to up the speed, but that also means I'm getting less signal to noise. So you scan a smaller area, you zoom up, you can like slow down the speed, get as many pixels as you can, and get the best possible image without it taking forever, right? That's always the balance with imaging. It's like, you can optimize everything to get the nicest image, but you also have, limited time in a day, right? You don't want a confocal scan to take hours and hours and hours. So you always try to find that balance. You want to go faster, you're usually going to lose some resolution or signal to noise. If you want the best resolution, you're often going to go a little slower. So those are all things to take into consideration. So does anyone have any other questions on positions, tiling?
You might be using the tiles to find our samples. So
Yeah.
we do it with the bright field.
You mean tiling in Brightfield?
Yeah.
Yeah. Yeah, so that's everything is the same except for you have to make sure you check that TPMT button here. So remember how before we did a scan where we had both the red and the transmitted light channel? So as long as you have this checked, all the rules are the same. You just have to make sure you have the TPMT. You could either say, you could also say, oh, I only care about the transmitted light. So you uncheck the other detectors, you just check that TPMT right there. So now I have a track that is only a bright field TPMT channel. So now let's see what our gain is. Should be channels actually 280. I think we used this same laser before. So yeah, there's our transmitted light channel. So same principle. I mean, you can see the overlay here with the map that we made. This is why I like to scan this map here, because now I can use a different track, but still look at what that looks like and easily go to like a spot that I find interesting, right? So, but everything here would be the same. Like if I have this tile region here, if I hit start experiment now, it's just going to scan everything in transmitted light. So you'll get a bright field image here. Heck, you could even say, if you want, say just a part of the map. So remember I made the map through that preview scan right here. You could use the same experiment. Let's see, right here, don't delete the original. And then if I start right here, let's see if I'm relatively fast. So now you see like a transmitted light channel map. Like if you want the map in transmitted light, this is what you would do. So now I could even overwrite the fluorescent map that I made. It doesn't really matter. Like you can say delete the original if you don't like it, if you want it in a different color. If I don't delete it, it will just like overlay things here. If you like the image that you use as a map, you could also save it. You could just like right click and say save this preview image. I mean, honestly, the main purpose here is to have a map to click around, but you could use this as data too, like it's still stored, right? So that's what you would do. If you want to like do an overview in Brightfield, this is how I would set it up. Like just have the TPMT activated, pick your laser line. Technically, you could use whatever laser line for transmitted light, but I generally use one of the red ones. Longer wavelengths use like lower like input energies, like less damaging to your sample. So generally longer wavelengths are a little better to use there. But you could do, let's say, like a 10x large overview scan in Brightfield, and then switch to say your 40x or your 25x and do like fluorescence at higher magnification. Yeah, does that answer your question?
Yeah.
Perfect. So now I think, well, there's one little thing I guess we want to talk about a little bit. Time series, that's honestly the most simple menu from these checkboxes here. Well, actually, let's leave the tiles on for a second. So if we have time series here, I check the box. Really, the main things to play around with are the duration and interval. And both are pretty self-explanatory. Duration is like the total duration of your time lapse. So you could either say cycles. That's just like, say if you set up a Z stack and you do 10 cycles, it'll just take 10 Z stacks in that spot. If you do minutes, right, then you will just have a time. Say you want to follow something for an hour and an image every 5 minutes. Within that hour, this is where you would say 1 hour, 14 hours. Whatever works, and then here you would set the interval. So within that hour, every couple of minutes, or you could even say, if you say 0, it'll just keep continuously imaging. Of course, for an hour, that will probably be a little too much. But I always recommend double checking this box here. You see how right at the bottom it says experiment information. This will calculate for you, like with your current experiment settings, like how big something is going to be and how long it's going to take. Of course, if you set a 1 hour time lapse, it says it's going to be about 1 hour for this experiment. That makes sense, right? But this is good. This is a perfect sanity check, because if you set up tiles, with C-stacks, with time lapse, with different positions, you want to double check, especially if you're reusing an experiment, if there's not like a tile region somewhere that you forgot about, or maybe your C-stack actually has a longer range that you expected. If the numbers here look really weird, right? Say this says that it's going to take a week. Well, I'm trying to do a 1 hour time. That means that something somewhere is wrong. So before you hit that start experiment button for any of these experiments, right? C-stack, tiles, time series, check this window. Check if this is normal, like either the time or the size. Like if your file is like 10 terabytes, I mean, totally possible. You could set up a 10 terabyte experiment on the system pretty easily, but that generally means like, oh, you're probably grabbing something bigger, or maybe there's the time lapse is set to a different range than you wanted. So always check this as a sanity check. It definitely helps out. This is why I also recommend building an experiment, right? Like first pick one Z-stack, see what it looks like, then add like different positions, and then add your time lapse. Like try to build it up. Don't try to do everything all at once, because if like one parameter is not exactly how you like it, you don't want to walk away, come back hours later and realize that you just have to, change one number in there. So that's always good practice. But those are really the main things in time lapse. Honestly, there's a couple other inputs here, but that's mostly for experiments where people send like TTL pulses or have like any other equipment attached to the microscope. So most of the time, yeah, this is not something you would really play around with. Maybe if do you guys ever add like a drug or something to an experiment? There are markers here that you could set. So in a time lapse, when you hit set marker, like you just add a marker during a time lapse, then you know in the time lapse, oh, this is where I added my drug. So that's something you could do under here. You could also, during the time lapse, while it's running and you're adding a drug, you can hit pause here. So it doesn't, so it gives you the time to like do whatever you need to do and then move it back and continue the experiment. So that's always nice to have. And then direct processing, I think we'll do with the Aries scan. Maybe we'll play around too a little bit with the auto immersion. So let's switch to our 40X. So we'll see it. Take a look. If you look at this objective, it's a good thing to just see what it looks like. You see the little tube here coming out. That's where the immersion comes from. Right? Yeah, you see here at the bottom, and you see the rings around the objective, like this little sponge here. That's mostly for like catching any excess that goes to the side, making sure that it doesn't run into anything. Yeah, and it's literally connected to a tube that goes into a pump here on the side of the microscope, and then coming from the reservoir right here. So you do want to keep an eye on that reservoir. You can actually see it does monitor the tank level. It's basically reading like a current that goes through here. That the more water there's in there, right, the better it can read out like, oh, it should be this value. Once it gets below a certain point, it'll say, oh, your tank is running low. And this bottle you can actually you can just grab and like pull out of it. Either there should be like a syringe around, like there's one that came with the kit, but you can just add DI water into that bottle, make sure that it's like filled up. Doesn't have to, you don't want it all the way at the top. Just make sure that there's enough in there.
So do it when the system's off.
It doesn't have to be off.
Oh, okay. So
it could
you can do that now.
Yeah, exactly. Like you could, because this is not really, it's not like it's directly hooked up to anything apart from like the pump that is on there. I mean, you don't want to use any of these buttons while you're like pulling this out. And you don't even have to take the whole thing out. Like you could pull it out only partially and then add it and then like move it right back or pull the whole thing out. You can see this little tube that's hanging inside that really like pumps the water out into the pipette that sits sits on the stage over there. But what's important too is to keep in mind that it uses the cover glass and then the distance to the objective to like push water in between. So it does need things to be like close to each other to get the water into the place where it needs to be. So this is always good to like keep track of what it's doing. Let's see. So when I change, right, when I change to that objective, it'll say change immersion. It says apply immersion, or this actually it says for any objective if you're changing between different immersions, because that's a basic setting that's always set for when you change to any other thing that requires you to do this. So it gives you a warning. Since we're using the auto immersion, you can actually say continue and create immersion. What that'll do is it'll move the objective up and then add the water on there. So we can see the drop. I feel like it gets a little right next to it right now. What we can do too is move it so that it actually goes off the lens. What I want is that water drop to be right next to where the lenses. We can add some more too. So if you hit that create button, yeah, it adds extra water.
And you can set the volume for that?
So it should be a standard volume. So there's no change here. But there's two different volumes here. So you see how it says renew versus create? So create is like a larger starting volume where renew is like smaller to add more to existing. Yeah.
So what is the volume of create?
I don't know the exact one. Let's see if they have it listed here, but it's basically just it's microliters, right?
Yeah,
It's just like a small.
Yeah, I mean, I saw in the amount that you put out the first time, and then it's like you did it again, so you put double.
Yeah,
Right?
yeah, and that's 2 times create. I mean, that's a fairly large
It is.
drop.
Yeah.
But it's hard to predict like how much. I mean, this depends on like room evaporation, right? Like we talked about that a little bit.
That's
So
why I was just curious.
how much
That's
would
why.
be when you would need like more, right? So that'll be a little bit more testing.
Because like I know how much I like normally put on. Sorry.
That's more than So the review, so you add a war.
Yeah,
okay.
renewal will keep adding, right? And then so if you do a time lapse experiment, you want to check this box here. So this will let you like set. Oh, actually, so it does do 500. So here you can. For the renewal, it'll actually let you set the volume. It doesn't let you set it here. It lets you set it there. 500 millimeters. That's weird. So yeah, that's not.
Yeah.
Oh no. So this is for X and Y. So what it'll do is this is mostly set up there for larger. Like if you do like larger jumps on X, Y, right? If you're going a certain distance, you're gonna move out of the drop. So this will renew. So if you have a larger sample and it knows you move beyond this distance, then it'll add more. Yeah.
But so you can't change the volume.
Yeah, I don't think the volume is here. No. It's like unless they change it in the software version, but I don't think so. But this will be so time. So like say like every 45 minutes adds. So and it'll run the renew volume, not the create. And then I'll look up what that is because it should be listed somewhere. But basically, this is your time indication and this is distance. The distance, if you're, I mean, it depends on if you have something. Yeah.
Well, roots are very long.
Yeah.
So you'll probably.
Well, it's possible. I
Yeah.
don't know how often that would be needed, but
Yeah.
the 500 millimeters.
500 millimeters.
It's
That's a large.
That's a very
That's a
long,
big jump.
huge,
Yeah, that's a big jump. That's like.
Yeah.
Because the main thing I think this is designed for is like also like plates, right? Like if we're going across a plate and we need water
We need
immersion,
more water.
those are going to be the
That's
biggest
gonna be
jumps.
faster. But on
Yeah.
a single slide, I don't think
No, like for now, for example, like I was moving around,
Yeah.
I could, that stays within the emergent for pretty much anywhere on this slide. So it doesn't really seem to be the case.
If you wanted to do group step all the way up. So go I like the tiny drop that I usually. Yeah.
But that's really the main, those are the main controls. I don't think there's anything else here you really do. It's like check this box and then you get this menu right here. Just make sure you know that where that lives. It's just this little check here. And it's independent of like the time series menu. So it's not like added every, you know, like it doesn't have to like coincide with an acquisition itself. Like it's very very independent, which you would want regardless. So those things, the menus look similar, but they have like slightly different parameters. Let's see if we actually have anything to see. Okay, that's good. So the engineer set a pretty good part focality because we switch between objectives. It looks like we still have pretty good focus. So yeah, if the focus was if this was very blurry between switching the two objectives, it's adjustable to set like the height of the objective when it like switches between. You always want it to be within about a quarter or so of the focus, turning the focus knob. So if that ever starts looking off, just let us know. Like the engineer, Mark can come in and just like set the part focality. That's pretty straightforward. But this looks pretty good. We can move around. The nice thing too is because we didn't move, we didn't take our sample off. So now that map that we took at 10x, we can use at 40x. And you can see right now, this is a 40x field of view, so everything kind of shrank down. But that's fine. Well, we can like have, this is why I like to take these overviews. So then once I'm on that higher mag objective, you can use that as a reference. So you can always pick out the interesting spots on your slide when you're zoomed up on the higher magnification. So that looks good. So we should move into area scan. So that's kind of our final chapter. So let me see. We don't really need time series here. Let's bring back our web here. It doesn't really matter. So if you start on the area scan, and actually what I'll do is I'll pull up one of the PDFs. This is also in that training folder. This just shows overview of what area scan is, right? If we're doing traditional compocals, what we've been doing up until now is we use that pinhole to cut the out of focus light and get optical sections. With the area scan, we have a detector, actually multiple detector elements sitting in that pinhole plane. What that results in is like every one of these individual elements are equivalent to a point to area unit pinhole. Of course, if you normally have a point to area unit pinhole, you're cutting away a lot of light. So even though you theoretically can get really good resolution, practically you wouldn't get that as much because you need a ton of light for it. The solution here is because we have all these different elements, we can let through that light and we can add them all together. So the final area scan image is the combination of all these different elements added together. But of course, they're all at slightly different locations. So they also need to be shifted. We know exactly where all these detected elements are. So we can calculate, okay, this is where the light originally came from. The only thing you do have to do compared to regular compocals is that you have to align the point spread function onto the detector, which means that we want the brightest spot here in the middle of the detector when we're aligning so that we can project how a normal point of light would basically where the original light came from based on all the information from the different detector elements. So when I'm talking about a point spread function, that's this thing that's displayed here. This is kind of the 3D representation. When we do the one area unit on the confocal, it really cuts the pinhole down to just create like grabbing this peak and cutting away this light, like these waves that we see here on the side of the peak. So that's where a confocal pinhole will lose some of the light regardless, but creates optical sections. Here, we're letting through most of the light onto the detector, and then back calculating where the light originally came from to reconstruct a super resolution image. Here it shows that again, like all these individual detector elements. This is just an example of adding those elements together and then processing it into a final super res image. But really, other than that, the area scan detector, so it means alignment and then it means image processing after collecting the data. Other than that, all your parameters, all the things that you're going to play around with, laser power, gain, setting up your tile, setting up your Z-stacks, same rules apply. The only thing is because it's a super resolution detector, that number of pixels is going to be higher. The sampling, that 1x sampling you saw before with the confocal, it's going to be 2x sampling on the area scan. Now, let's see, I don't think it's in here, but another thing that we can do with that area scan detector, actually, let's see if we have, no, it's not in here, but basically I'll point it out here. If we have all these multiple detector elements, right, and we scan a spot, like if we just use area scan in normal mode, it'll just do 1 pixel at a time. However, we have all these elements, we could actually project multiple pixels simultaneously onto the detector, which means that we can scan faster. Of course, when you pick up multiple, like reconstruct multiple pixels simultaneously onto the detector, that also means that you cut a little bit into the resolution of your final image. So this is why AirScan has both super resolution mode and then a mode called multiplex. I like to just call it fast mode because it goes faster. If you use the 880 with AirScan, that's where it was called fast mode. Very similar technique, only on the 980, it has basically an extra speed mode. It can go a little quicker compared to what it could do on the 880. But we'll see that in the software. So we have AirScan super resolution and an AirScan like faster. And depending on what works best for your experiments, you can kind of play around which one of these modes works the best. So to set up AirScan, we'll just go through Smart Setup as a starting point. So here you see at the top, we've been just playing around with confocal mode. We're going to pick AirScan. With AirScan, we get this triangle right here. That's honestly the biggest difference in Smart Setup. This triangle represents the different modes of the AirScan. It's just like when you're back in grad school and you have the triangle of getting good grades, getting enough sleep, and getting a good social life, right? This is the eternal imaging triangle, like what you want to prioritize, like the resolution versus speed versus signal noise. Practically, I'd say there's only really 2 choices here. It's like this corner, AirScan SR, super resolution mode. That's the highest resolution. Good for fixed sample, something where you're not trying to like capture fast moving things, really trying to get the finest detail. Where speed is really the fast mode of the AirScan. The reason I say there's only really 2 options is because all these other ones are a bit in betweenish. Plus, you can even, if you pick that as R mode, it's only 1 button you change in the software to really hit that confocal mode. That top mode here optimizes for sensitivity. What it does there, it uses the AirScan not to get the highest, finest resolution. Like it actually uses the same amount of pixels that a confocal would do. But because the AirScan is highest sensitivity, you can capture like weaker signals better with this mode. But since you can just activate that within the SR mode, honestly, in this triangle, I almost never go to these options. The other ones that are on the middle, they're all called multiplex 4Y, multiplex 8Y. Those numbers just stand for the amount of pixels that it grabs simultaneously. So of course, 8Y would be quicker than 4Y. Then there's something called confocal 8Y. That's the quickest mode. That's the fastest scan mode on the AirScan. As a starting point, I'd say that's good to start out with. But if you pick that mode, we'll just pick it right now so you can see what that looks like. if we pick that mode on the area scan, we will see here in that acquisition mode screen, you actually see the other modes sitting here as well. This is why on that triangle, I'm like, you can always start with that bottom corner and then pick one of the other modes here to go. So 8Y, 4Y, they all live here. And generally, I'll put the speed to the maximum here so we can crank out the most speed. You can actually see also on that 8Y, so that's the fastest mode at maximum speed. It's around 300 milliseconds full, or yeah, our current frame. So actually, this is a 2x zoom. So for scanning, again, that's really nice and fast, especially compared to like confocal. But if we then look at the SR mode, so we'll go to super resolution mode. Let's do best signal in this case. You also notice that there's no fastest option in the smart setup. This is because ARIES can act as a single detector, right? You can't send the signal to multiple detectors if you're just using ARIES scan mode. So that fastest mode won't be here. You can still use this, obviously very speedy mode, but it won't be like one of the options here in the smart setup because you can't do multiple channels simultaneously. Best signal and smartest still mean the exact same thing, right? Best signal, everything gets to be its own track with its own settings, own filter settings. Where smartest, generally on the area scan, will just let through all the light to the area scan. It'll only switch between the lasers. If you do, say, just a green-red, there are some filters that are dual bandpass. Actually, most of the filters will be dual bandpass. So it can actually put a filter in place still and then just switch the lasers. So that's also totally doable. Usually, if you have 3 or 4 colors, it'll just let through all the light to the area scan. So let's go to best signal here, see what it looks like. So now you'll see, instead of just the confocal button that we saw before, now it's SR and confocal. SR will have 2x sampling. You can also see right now we have like 2000 pixels by 2000 pixels, where confocal is going to be exactly half of that. Now we would be sampling at confocal resolution. The software will actually say area scan acquisition is not configured optimally. It's because it knows, like you can totally scan this way, but it knows that you can get a better resolution, right? If I hit SR, it'll actually say, oh, it's optimally configured. But generally, this message, like I don't say you have to always listen to the to this say, because it's more just saying like, oh, you could get a better resolution out of this channel. So now let's see. Okay. So what we should do is look at like what ARIES can look like when we go live. So there's a couple things to keep in mind. You see here, right, the tracks say SR instead of confocal, right? This is how you can also tell this is ARIES scan. ARIES scan picked in this best signal mode, it picked filters per channel. So you can see here, you see how this is cut off right here. It's because it put a short pass filter in place. If we look at the light path right here, that's this wheel right here. So it can use short pass, long pass filters here, and this is all dual band pass filters. So remember, right, like AirScan uses these filters where confocal uses the sliders right there. So that's all represented here. So this drop down here, first filter wheel, drop down here, second filter wheel. Generally, smart setup, if you do best signal, it'll pick a good option there. But you can play around with these filters. If you don't have that many colors in there, you don't expect as much bleed through, and you want a little more signal, you can get these filters out of the way. The way to do that in this case, you would pick a plate option. Plate is always just a glass plate that lets through the light. So if I pick plate here, see I let through all the signal on this track versus that short pass that we had before, right? So I'd say starting out, smart setup will give you good settings, but it's definitely worth just like playing around with some of these filters just to see what works well. Then let's go to our red. So if we look at the laser powers, generally AirScan I start relatively low. Gain on area scan. So if we're doing confocal is usually, I mean, 700 is a starting point. 600 to 700 is good for confocal, but area scan we can get away with higher gains. Generally, I'd say 800 to 850, totally fine to use on area scan. That would be high on a confocal detector, but on area scan, totally fine to do. Then of course we want to look at alignment. I think that's a really important thing to do on the area scan. You'll see this little drop down or like a little arrow here right next to that honeycomb pattern. So that's a representation of the area scan detector. When you hit that little arrow, you get this menu here. It says adjust in live and continuous scans. What that means is it'll automatically align the detector while you're in the live window. So you don't really have to do anything. It'll automatically set up the area scan alignment. And this is important for getting right like the final super resolution image. Let's go live and see what we see. So that looks good. So generally see how the sliders move. And what they're trying to do is get that bright spot right in the center. That's all it's really doing. Once this turns green, you're good. You're done aligning. That's honestly all you have to do. If you have multiple colors, right, like a single color, this is really simple. You align here. Once it's aligned for the rest of your sample, you're done. Like I wouldn't even do any more alignment. I would just uncheck this here. That'll remember the alignment. It'll just keep this consistent. It's literally like just two steering mirrors in the scan head. You just uncheck this button right there, and then you're done. However, if you have multiple colors, they can have slightly different alignments. So there's two ways you can set up alignment for two colors. So if you have, say, green, red, bar red, dappy, it's hard to do like scan all of them at the same time, right, and get a good alignment. It's totally possible, but it requires something like running in continuous, running in line mode because I don't want the frame switching, switch the filters between all the channels. So the best thing to do there is pick one of the middle colors and have the alignment sit in the center. So either red or green in this case. We can go to green just to see what the alignment looks like. Oh, very bright. So we're gonna turn this down here. It's already green. So green and red are generally pretty close in alignment. So you could see we had already aligned the red. We would be fine for the green for that same channel here. I just want to show it just to show that it's not very different. Again, this looks good. Alignment looks good. I just uncheck this button and then use this alignment for the rest of my scanning. You can set up a Z-stack. If we go, and I'll show that just quickly. If we go to the Z-stack, move through Z, and look at the alignment while that's happening, right? Remember how I unchecked that box, so it's not going to adjust it while I'm going through the Z-stack. So see, when there's not much signal, you see the alignment gets all over the place, and it'll actually say, oh, there's not enough signal. That's totally fine, as long as you have alignment set up on one of your colors. That's because when there's not enough signal, of course, it can't align much. The thing you want to avoid is checking this box and then trying to align somewhere where there's no signal. Because then the alignment, like these little steering mirrors, they'll just go all over the place. They'll try to find alignment when there's nothing there. And then when you actually hit start experiment, your alignment will be very off. So try to get your alignment, like try to find your brightest spot. You can run it either in live or continuous. Generally live will be quicker, but you can just do one color. That's totally fine if you have a middle color. But if you have, say, the faster mode of the area scan, there is a way where you can align multiple colors at the same time with continuous. But I would honestly only do that if I can know that a continuous scan goes fast enough. You can imagine, right? So if I hit live and it's doing this adjustment, it changes these positions in alignment every frame that it scans. Now, if I'm in live, it takes almost no time to scan one frame. If I'm in continuous, it's generally going to go really slow, right? It's going to switch between filters. It's going to try and do like the pixel number that we put in here. Right now, it's just doing 512, 512. That I can do really, really quickly. So generally for alignment, you want to either be in live or set up your settings so you can do this really fast. So one other way to do it So right now, let's do a quick experiment where we just do, let's do the red actually. So we want to run this, say if we run this in continuous now, you see how the frame time is 9 seconds? Let's do bidirectional so we go a little faster. We only have one color. So if I hit continuous right now, it's going to take multiple seconds to take this frame. So if I'm trying to do the alignment right now, of course the alignment is already good, but if it's trying to align, it needs to wait every time until the whole frame is scanned. So you don't want the alignment to go this slow. So the trick there is if you want to do alignment in continuous, you want to zoom up. Basically, you zoom, say like a 5x. Now, that same frame in continuous will take less than a second, right? Like half a second. So that refresh rate is a lot quicker. So that's one trick to really do the alignment quick and continuous. And I'll show you like the situation where you would need that. So if we go to smartest line, now I can actually do continuous for multiple colors at the same time. I'll get rid of our far red because we won't see much there. Red and green, that should be good. So now look at our refresh rate, which sits as about 1.5 seconds. And this is at 5x zoom. So if we now go continuous, I can actually, oh yeah, we have way too much green. Let's see, let's turn that down a bit. Green is so bright in these plants. There. Look at the alignment. See, we can now see it for both. So this is really, if you want to like optimize it, this is like, I'd say the perfect optimization is if you do it for all the colors at the same time. But in a practical situation, especially if you have a range of colors, I would say the middle color, quick and dirty, doing the live alignment is your quickest way. But if you want to do it in continuous, I would always go line mode, run continuous here, and zoom it up to a level where the refresh rate is about a second or so. A second, like less than a second, always good. 2 seconds starts to get to the point where it takes longer, especially if it takes like 10 seconds, then that's not worth it. It will take too long. But now you can see that between different colors, it'll align for both of them to make sure that you have alignment for all the colors. There is an exception. I mean, I can't really do it with this plant sample for Gappy. I mean, I put some instructions in a PDF here. Let's see if we can see that.
But if the bright spot for different channel, different color is different.
Oh, you mean like yeah? So you do want to find. I mean, red and green. I would say if you align on the green, you're good.
Okay.
If you're zooming up and you don't have something bright in the sample, there's not much. Yeah, you would have to zoom out a bit. What you can do instead of zooming, you can also change the pixels. So remember, we have sampling here of 2x, 852 cycles. So actually, let's do that. So I'll show you what happens. 1.7. Right now, it takes 12 seconds to take a frame. So look, I hit continuous, right? This takes way too long, right? I'm not going to wait until this aligns. So you don't need 2,500 pixels. You can go way lower. You can actually say 512, 512. Of course, it's going to say, oh, it's not optimal configured for area scan. It doesn't matter. We just need to get a decent refresh rate. If I now go continuous, see, now this refreshes really quickly. I can actually say, oh, let's adjust the zoom a little bit. Let's move somewhere. So you don't have to zoom in. You can also play with the pixel number. So that's the other trick you can do for alignment. As long as you're in the green here, if this is green, you're good. Uncheck that button, and then you're good for the rest of this sample. If you're imaging samples that are exactly the same for same intensity, you don't really have to change this anymore. Only if you go to like a very different sample with different fluorophores, different staining, anything like that, then you want to redo the alignment. So that's really the major thing for the area scan compared to confocal. Like confocal, obviously you don't touch any of, there's no alignment step or anything like that. Area scan, you wanna run that alignment. Make sure this is green. Once this is green, you're set. Uncheck the box, and then you can image wherever you want on the slide. Should be in good shape. All the other parameters, same rules apply as confocal. You don't want saturation. Saturation is actually for area scan even worse than it is for confocal, because if you get saturated pixels, the processing will actually think that you have really, really good signal, so it will process a lot. Like it'll do very strong processing, so you can get like over processing if you have saturation in there. So generally, when you go live, see, like this looks pretty full already. Like I tend to go like, again, like about like half or so on my intensity. So I know this green is just really screaming bright. So you see the laser power is like 0.11%. The gain is at like 600, very low, and we still get a chunk of signal. Area scan is generally more sensitive, so we'll pull more signal out of a sample than standard confocal. So overall, laser powers will generally be lower on the area scan compared to regular confocal. So that's good to keep in mind. But you'll play with the same parameters, laser power, gain, and that's where it'll sit. Then let's see. Other than that, here, yeah, anything here, all the other things, C stack, pretty much the same. Tidying up, nothing really changes here except for that interval time or interval range will be, of course, like smaller for the area scan because that's higher resolution. So those numbers will change a little bit if you go from confocal to area scan, but the rules apply exactly the same. If you highlight this, it'll calculate the optimal step size for your sample. So that should be good. Let's get rid of these tiles here actually. Actually, so if we close tiles here, it'll want to get rid of our overview in this case. So it depends. I mean, right now it doesn't really matter so much for my imaging, but if we wanted to keep our map, we really want to keep that box checked, even if we don't have any tiles. And it'll give you that warning. If you see this, like, do you want to save your preview? It usually means that it just to close that window up there. I'm not gonna save these. So that'll just leave the stack. So when you collect area scan data, so this is just an area scan frame that we scan in continuous. You can recognize it as area scan data because you see the area scan tab. Area scan tab, that's really where you see where you can process the image. This is where it'll decide the processing strength, all that stuff. Generally, I would optimize first. Let's take a little Z stack because what you see here to create a processed area scan image, what you see here is a preview of the processed image. It only says current image 2D. What that means is we just have one slice. Once you have 3D data, and I always recommend for area scan to get at least some 3D data, it'll have an option for, let's see, let's make this small. Center where we are. Maybe one or so. I just want a couple slices, maybe just a red. So then I think you need a minimum of five slices. Let's also make sure red is aligned here. There. You can see the signal here. It could be a little stronger. Your gain is really low. I'm gonna crank that up a little bit. That's perfectly fine. We have SR mode. That's a lot of pixels. Zoom it up a little bit. Basically, I'm trying to make it like a little faster so we don't stare at a C-stack collecting for a long time. Always make sure it's set to optimal. Make sure there's no random tiles. We'll just start this one here. And So now under the dropdown, you'll see current image 3D, right? Because we have 3D data. That's generally what you want on the air scan. The other thing you see is that little auto filter here and a super resolution value. In this case, it's like 6.4. It decides basically based on your input signal, the noise, what a good number there is. You can uncheck this and pick your own. I would say starting out, leave this auto filter on, but if you want to very consistently process every image exactly the same, you want to match this this value right here, like the number that you pick. And again, this depends on your sample, right? Like if you say you do like 5 or 6 C stacks, one lens at like 4.4, 4.5, 4.6. If you want to kind of pick a middle value, but generally as a starting point, autofilter totally fine. If you're doing quantifications of intensity, again, there you want to have the exact same treatment. If you're just looking at structure, autofilter is totally fine. You pick current image 3D, and then you hit create processed image. Then you'll get a processed version of the image that is just has AirScan processing in the name. That'll make that'll basically be the final AirScan processed image. So really here you don't see that tab anymore. So this is how I know, oh, this is my stack, right? This is my stack that's processed. This is something you can open in Fiji or whatever other software. If you try to open the raw data, so anything where you still see that tab, you don't have that AirScan processing in the name. Things like Fiji will get kind of confused. Like they don't understand the raw data of AirScan. They can't read out all the different elements. So it's always good to run that processing step, save that file as well. I would still keep the raw data too, just to make sure that you can always go back, reprocess it if you need it. But that's really the important difference here. Like you generate a processed file, and this lets us also get into the direct processing because right, this is the manual way of doing it, right? Like you have the raw data, your raw AirScan data. Then click create image, either 2D or 3D. Generally 3D for any stack, any 3D data will be a better, higher quality, better resolution image because it's a more advanced algorithm. It uses information from above and below what you're scanning. 2D will just process a slice and ignore all the information from above and below. But if you just have a snap, that's your only option. It'll still be improved resolution compared to a normal image. But best quality AirScan data will be 3D data. But yeah, going into direct processing, let's see if everything is working on the other side as well. See if it finds anything. Oh yeah, that's fine. So what it tries to do now is like, well, we need to make sure we have a connection with the other computer in the other room. It should be on. I think we turned it on yesterday. But if it's off or anything like that, like you'll see like this will not be green. It'll basically like show you a red cross here saying like I don't see the other computer. Technically, this computer can also do the direct processing, but then of course you're making this guy multitask, right? Like it's both acquiring and processing at the same time, which generally I don't recommend. For basic stuff, it doesn't really matter, but the bigger a file gets, the more the computer's going to struggle. And then if it's also trying to acquire your data, that can interfere with each other. It's more likely to crash the software if you're doing it that way. Now, if you have remote receipt checked here, it'll try to send it to the other computer and have that do the processing work. You want to make sure you pick AirScan processing here. 3D processing because we're using a stack. Then there are some options here for how to handle the final image. Generally, the default will be just open the final one. So once it's done, it'll open the processed file right here on this PC. Split view will have the raw and the final image in one view. And you can also set it like, oh, I don't want to open it manually, or not automatically, but generally it's fine if it opens here. One thing you do want to double check is the output folder. This is the autosave folder. So if you go to this little autosave menu here, this is where it will put the data. make sure you pick somewhere that makes sense to you, right? I think everyone has their own file organization. I generally just recommend picking the network computer, right? So this, let's see, where is it? Swap, right? We talked about this, like the swap folder is the network folder. Then there's already a data folder. I'm just going to say the Zeiss test. That's where I sent it before. Always pick something here. Don't leave it on new. New is the worst yet. That you're gonna go crazy because all your files are going to be new 1, new 2, new 3. As a minimum, I put like the objective here. Maybe say that it's the 561 laser or what kind of sample. You can put all kinds of information here. What it'll do is it'll put this in the file name and then add a number for every image that you take. Once you check direct processing, it always automatically activates that auto save. So that's a nice thing. You don't really have to remember that it does that. It'll always do it, but it's always good to change this right here. Make sure you change these parameters. Otherwise, you're gonna have a bad time if you're gonna look at your data later, right?
Yeah,
So-
we'll have that. It's a good thing.
Okay, good, good. That's
If people are naming their files, do anything.
Gonna be in trouble.
yeah. That's yeah. Anytime I see that in a folder, I'm like, no, no, I can't. There's some more things like you can add like these parameters. Like there's these so-called like format IDs that you see here, like percentage n. That's basically just the original name of the file that it puts in. But you could put like prefixes. You could even say, oh, add the current year or the date to the file name. So if you want to add that automatically, these are the tags, and then you would just say like percentage and then that tag in here. That's really it's really nice to have in there. And the good thing is even if you don't use direct processing, you could just check autosave for any application. You just do it using Confocal, doesn't have to be AirScan or anything like that. You can just check that autosave. It'll just autosave any experiment that you anytime you hit start experiment, it'll save the file. The only thing that I don't think it does well, if you run experiment and then make modifications after the fact, unless you like generate a new, if that generates a new like processed file, those generally don't autosave directly. Like it's usually tied to like your start experiment. But in the case of direct processing, it'll always save that direct processed file. So if the connection is not on, because this will eventually happen, so I'll definitely show how that works. So right now the connection is here, but if it's not there, hit edit connection. You'll generally see at least one of the computers, like it'll see itself. That's the bottom one. Like you don't have to remember this IP address, but this is basically the bottom, this one right here. You do want to remember this IP address. If you ever forget, I mean, I took a screenshot of this and saved it in the training folder. If you forget this number, you'll see it on the other PC. So on the other PC, when you go to Zen, and I'll show you where to find it here, because it'll look exactly the same as here. Go to applications. So on the other PC, go to applications, look here. It'll see under direct processing. Here you see that it's like 164. I mean, over there it's 192.
Yeah.
168.
96.
96. Yep, exactly. I know. These come with like standard network addresses. So that's the number you want. You don't want the one here. You want basically this number, but then noted on the other PC. Then type it. So if it doesn't show up here automatically, type it here at the bottom. So 192.168.9643, and then port is 8000. Yep. So exactly what you see here. If it doesn't show up, type it here at the bottom and hit add. If everything's properly connected and booted, it'll just populate here. Then all you have to do is hit connect and you're good. So right now it's already working. I mean, we set it up yesterday, and usually as long as things are on, nothing would change. But I could imagine if if someone powers the system down or doesn't boot Zen, it'll try to find it, but it won't find, So just remember all of that is under this edit connection, and then type it here, hit add, and then you should be good. You don't have to, don't mess with the discovery proxy or anything above there. Those will just try to find other things. So yeah, I would always go through the bottom here.
So for the other server,
Yeah.
so should we, so when you do the process, so don't, so maybe when we set up to don't turn off the display, don't turn off the, the Windows have like those setups, so we should turn everything off. like,
Oh yeah, so it doesn't go
power.
to sleep. Yeah.
Right, right,
I mean,
those
the
right.
monitor, of course, for this, the monitor doesn't matter, right? Like we don't, I mean, it's good to check. This is what I did with the engineer. I literally had him sit next to the computer because you'll see once it's working, right? When you hit start experiment, it streams the data. You see on the other side, you see like a little bar under this menu, the same menu here. You'll see current request and it'll have like a little loading bar that is doing something. That way, you know everything is working. But I don't recommend like running between these two systems to see if it's going right. And it'll spit out the data here once everything works as it should. So I would leave yeah, I would leave it running. I mean, it's totally fine. It's totally fine to turn the microscope or the computer there off, even though the sticker says like, oh, don't power it down. But just make sure that before you try to do anything here, that it's booted and then it's started. Yeah. Yeah. And if this doesn't show up, just type the number as I just described. That's honestly, that's all we did when I came in here, and it works flawlessly. The only thing I would worry about is if someone actually unplugs one of the cables, because that's hard. That's really hard to check from any computer point of view. Or most notorious culprit is if someone changes network addresses on the ports, because then we actually have to go into other settings to adjust, right? Like if it has to talk to a different networking port, that means we have to do some Windows stuff. Because the networking, really the two computers talking to each other is mostly Windows based. It doesn't have that much to do with Zen. Zen can talk to the other Zen only because the two computers can talk to each other through Windows. And Windows likes to do updates and all other things, but that doesn't really talk to you about. So it's good to just keep an eye on, is this like, does it show up as it normally shows up? You can even go to what's it called, like the command prompt, and just like type ping and then the address, and then they should be able to ping each other. If that ping is not working, then there's like a direct connection issue. Sometimes there's a firewall issue too. So if you run into anything like that, just let us know. We could either have someone who remote in or drop by if we're in the area just to make sure that the networking is working well. And once you have this running, when this is green, I could actually do the exact same experiment I just did. So it'll just stream the data. So now, usually it'll take a second because it's like trying to set up the communication between the two, making sure it goes. It'll collect our data. And now instead of me taking the data and running the processing, it should auto populate. I don't know, it's not a great C stack that I made, but this is mostly for running the processing. Let's see, so this is the actual acquisition. And now we actually already have the process in it. So now didn't really have to do anything. Yep, that's all that is. So basically, as long as this is activated, this is green. Just hit start experiment, and your process image will show up here. I mean, for something short like this, doesn't really matter. But if you're doing a little long, like time lapse, anything like that, this is really nice to have. So yeah, that's really the whole concept there. So we're getting close to 3. I think one quick thing I want to show is the faster mode of the air scan. I mean, it's very much the same as everything we just did. It's just quicker, and you have to. There's like a small difference with the laser powers. But does anyone have any questions on just area scan in general? And
I mean, I think I'm gonna have a lot more questions about AreaScan, but I haven't really used it, and I want to look at how it looks with actual frequency.
Yes,
and not-
exactly. Yeah, exactly. You want to look at it with your data because then
Yeah.
you can see
Yeah.
what it looks like.
Yeah.
Definitely do that. Like play around with your sample
Yeah.
and see how it comes out.
Yeah.
because that's the way to do it. And again, we'll do a follow-up
Right.
session, and I think then we'll use one of, I think for both of you, you have very similar samples, right? Like, so we'll use one of you guys' samples to like go through like the workflows that you want to do on that, and then, you know, giving you some time to play around and see how things look.
I have a quick question, Julia. We were talking earlier about like the root's 3D, right? So we need to go in the middle often to see.
Yeah.
So in this sample, it's pretty flat, right?
Yeah.
So with area scan, is it fine? Like, can we go in the middle of our sample and still
Yeah.
get really nice quality?
So
pictures here?
so the Z stacking and moving around for an area scan, not that different than standard confocal. It is more sensitive, so sometimes if the signal is weak, getting a little deeper, it can help a bit. It's not like 2 photon, anything like that, where it can, you know, you can get like 100 micron deeper or something like that. But since it is more sensitive, you might get a little nicer signal from deeper within. Also depends a little on the wavelength and how much scattering you have, that kind of stuff. But yeah, the like depth, all that stuff is very much the same. There's no real like difference, like, oh, you have to think about this with the area scan versus the regular confocal. You will have more slices. So when you go to that Z-stack menu, that optimal interval will be shorter, just because the area scan can get better resolution on those individual slices. So you'll notice a difference there. You're like, oh, why is it now more slices for the same area that I'm grabbing? This is why that faster mode of the area scan is nice, because you can go through the Z-stack really fast. So we'll quickly do that too. Let's see if we have, maybe I have already. No, let's do
We
this
do
one.
the time course with the air scan,
Yeah.
and so they also, so they, based on how you set the frequency or interval or something, so they generate the process the image every time for each. Or they do.
No, and you'll get a final image with
Oh.
the time points will be like a slider. You could try, like, you could split it out. So remember that experiment designer that we looked at earlier? You could make it loop through, but then that doesn't play nice with the direct processing. Like if you have separate experimental blocks.
Oh.
So you could have it basically, so you can tell it to project every time point as an individual file, and then you could open an individual file. You could even be on the other computer and grab that individual file and process it and see what it looks like. But generally for the direct processing, it'll just run while the time lapse is running, so that you don't have to, at the end of the time lapse, run the full thing processed, but actually it'll spit it out pretty quickly after the time lapse is done. Does that make sense? Like once it's done, you get the file really quickly versus you having to come in, click the processing, and then wait until the processing is done. Especially if it's a large file, it can take a while. I mean, it's not like hours and hours or anything like that, but it'll take time depending on the size of the file. If you do the direct processing, usually, I mean, you could see it here, it came out pretty much instantly. And you don't have to do any extra steps. So it'll just be faster. Plus you don't have to be here. You could be at the other PC and just open the data there, because you'll see it in a network folder. That's why I like having the PC's network too, because you can access everything that's been generated here over there. As long as you have that auto save, right? It'll spit it out in that folder and you can just open it right there. That's always handy to have.
Yeah, I just don't know, like, you have the experiment, something will, fluorescent signal will show up like a 2 hour, and after maybe 4 hour diet, and the other signal went up or something. So that's why you report so you don't want everything you tie it. And
yeah, exactly.
4 hours.
So if you look at the raw data too, let's see. So before it'll generate this file with the raw data regardless. This will also give you a preview. So if you do like a time lapse, you could check these time points in here in the raw data. It won't be the final super resolution image. So it might look like a little grainier, for example. Like the image we're looking at now is a preview image, but if you look at, I mean, it's not going to look that different, but if you look at live area scan, for example, if I just go to like a live scan, let's see what it looks like here. Let's see if we actually get some signal, because we just switched to the faster mode. Oh. There, yeah. So this is something you can always see live, but this is not a super resolution final area scan image, but it wants to show you something, right? So because that way you can adjust focus, like all that stuff. So what it does here is does a quick addition of all the like different detector elements without any processing. So this is just like a really rapid way of seeing what you're like having a preview of what it's going to look like before the processing. So the same thing you can do with the time lapse. It'll generate that raw data, and you could look at the time points before they're processed. So that's one way to check. Because if you don't see signal here, the processed image also is not going to have anything, right? Like you cannot turn nothing into something. There's no like the microscopy magic, right? Like you have to have some light information to get a super resolution image. But you can already see, so if we're on that faster mode of the air scan, this is one of the big differences. If you look at the laser power, you see how it says 0.2%, but equivalent laser power in confocal mode is 0.02%. This is because we're scanning multiple pixels simultaneously, and because of beam shaping inside the scan head, the laser power is also divided over those 8 pixels. So that means that equivalent to confocal, the same laser power is actually in one single spot lower. So that's what it's displaying right here. You can see it's relatively low, and we can crank it up a little bit. I'm still getting a big chunk of signal, which is good. But you can also see, because it's going now really fast, if we look at the frame time here is less than 100 milliseconds. Right? Before, when we were on the regular area scan SR, it was like maybe a second, maybe half a second, depending on our zoom level. Here it goes multiple degrees faster, right? So that's really the big advantage here. If we're just using confocal 8Y mode, right? This is the fastest mode. If I now do that same Z stack, let's see if our Z still match, and it should be pretty much the same unless anything really shifted. Now I'm just going to do everything the same. Data processing, all that is the same. Channels, I'll throw the green out because I didn't optimize it. And basically I'm going to do exactly the same we did before, but now with the faster mode of the area scan. So honestly, I think the most time it's going to spend is connecting with the other PC, because the actual acquisition is done already. Yeah, this is like it just does everything so fast. It can't even show you the acquisition while it's going a lot of times, especially if it's like that short. And again, the processing already happened. So this is like a big jump up, and if you want to get like through Z-Stack really fast and you don't need the highest resolution, this is a really good mode to use. And again, you can improve this a bit, right? Like here, say like 30 milliseconds, really fast, right? But you can always say, okay, let's go a little slower, add like a little more laser power to get a little more signal to noise. You can even say like one of these in-between modes, right? Like SR8Y, you can see this is more pixels, so higher resolution. It goes from 30 milliseconds to 62 milliseconds, which is still really fast, but you'll get a higher resolution image. So these are all parameters that you can play with for the faster mode of the area scan. The only limitation here is that, well, on the regular area scan, you have very much free control on these pixel numbers. Let's see if we can mess around with this a bit. See if I go lower. Oh, okay. So yeah, it does have a minimum amount of pixels that it wants to do. This has to do with like the amount of lines that it's scanning. So if I go to 512, it actually jumps to whatever the lowest number on that confocal resolution is. So you're more bound to like the pixel sampling that it wants to do either for confocal mode or SR8Y. Where the area scan SR mode, you can put in any number that you want. You can undersample a lot. Here, it won't let you sample under 1. That's honestly the most, like the biggest difference is in this menu right here. Other than that, again, everything else is the same. Setting up Z-stacks is the same. Setting up tiles is the same. One small difference is when you go to the alignment, it'll look a little different. So because we're using like a beam shaping on the detector, we won't see like the full detector representation, we actually see like a stretched version of it. So if I go live here, see now it looks like it's extended versus like round. The principle is still the same. It tries to get the brightest spot in the middle. It also turns green when it's good. Once it's green, you can uncheck the box here, and then you're in good shape for area scan imaging. So all the other rules apply here. It just looks a little different here. Nice thing is because this is faster, it is easier to get a good refresh rate for the alignment. So remember we did some tricks before where we zoomed in or we changed the pixel number just so that we can get a good quick refresh rate to get the alignment set up. Here you don't really have to do that because we're already at a really high refresh rate. So that's really really easy and quick to do. So that's really the main thing with the
But if you switch, when you do the fast mode, we switch back to the super mode, so do you have to do alignment again?
So it'll be very close to
Very close.
Shutter, but I would rerun it just because it might be if there's like a small
Still,
exactly. I would just double check. Generally, if everything else is the same, I wouldn't expect it to be very different. But usually, if you switch between these modes, you do have to go through like you don't click it here, right? Like you don't just say SR mode here. Like these are all fast modes. So you have to go through Smart Setup. The only thing I would want to double check is if Smart Setup picks like slightly different parameters and right, like because the colors here are the same, but for best signal, like probably the pixel number is going to be slightly different. So there's going to be some changes in most parameters. So like laser power, for example, is going to be different, right? Remember, laser power gets divided when we're in that speed mode. So I would double check the alignment for sure. Sure, because all of those things change a little bit. Yeah. But other than that,
I'm not lost. What is it?
Hmm.
Because in channels, when you're using the fast area scan, it says MLTIS.
yeah,
SR.
multiplex. Yeah.
Multiplex.
Yeah,
But
multiplex.
those presets button, they still say SR for Y and AY. Right?
Yes, these are all. Yeah, so these
You
are.
just mentioned that in this mode, they're both for fast area scan. Also, it says
Yeah.
SR.
This is all fast. So SR, I guess the way to remember it. So SR is super resolution, right? So what that means in general terms is it'll do 2x sampling. So it'll sample double of what normal confocal samples. Confocal is always 1x sampling. So any confocal mode will do 1x sampling, and that will kind of be your max. Scan super resolution, 2x sampling, independent of the speed. If you go to CO8Y, which is like a fast mode with confocal sampling, it is the fastest because it has to do 1x sampling versus 2x, just half the pixels. So it'll be a lot quicker. It is still using that multiplex mode. This is why I don't like the name multiplex. They used to call it fast, and then they're like, we have a new version. We're going to call it multiplex now. And then everyone who does like multiplexing of fluorophores is like, oh, is this for multiplexing fluorophores? No, it has nothing to do with it. This is why I like fast. Just call it fast. So really, all these modes are faster modes. So if anytime you see anything with Y, faster mode. So 8Y means like 8 pixels in Y simultaneous scan. 4Y means 4 pixels simultaneous. So 8Y is going to be faster, right? More pixels at the same time, you're going to go quicker. If you are in super resolution mode, it won't say anything with a Y. It will just say super resolution or confocal. Similar to this, super resolution to confocal. It's just the sampling that is different. That makes sense? Yes. Perfect. Perfect. Yeah, that's really the main difference. But that's a good question. Again, Germany will make things a certain way. I don't always agree with that, but that's why I'm pointing it out because it makes it easier to think about, like, right, if you have fast versus for the super resolution mode, and then confocal versus super resolution sampling. It's always good to keep in mind where is my sampling sitting? Like this, here you go from 2 to 1, right? And that's really the range. If I move this slider, you can actually sit in between a little bit. So now it's in between confocal and super resolution. So you can play around with these numbers a bit, but generally, you're gonna do either this or that. You can actually hear inside the scan that you hear the optics changing. That's the beam shaper. That's like shaping that beam onto the area scan detector to line it up for those 8 pixels simultaneous. Of course, none of that happens when you're in AirScan SR mode. So if we go back, we pick this super resolution mode, switch here. Now we just have these two options here. This is where I was talking about if you undersample a lot, you can do that in this mode, right? I can say 512 by 512. Can't really do that in that speed mode because it's tied to those specific sampling speeds. Here, it doesn't really matter. And of course, if you're going to use a super resolution detector, it's kind of a waste to do a 512 by 512. You might as well do confocal at that point, right? Because you're sampling way lower than the super resolution detector can resolve. So you're not gaining much from the power of what that detector can do. So generally here, you're going to be more in that 2x sampling realm. But there are nice things you can do with that confocal sampling is you'll get more sensitivity out of this detector than you would get with the regular confocal detector. So that's what this why this option is there. That's really what that is.
And going back to the question, when you're doing a C-stack and you're doing the area scan processing, it will give you only one image out of the C-stack.
No, so
Convert 3D.
So if we have, let me show you, I think we just made a couple Z stacks, right? So it'll be one file, but you have all the individual slices, right? Like, so you see here at the bottom, there's a slider for the different slices, right? Like that lets me move through Z on this end. I mean, this is a tiny, tiny Z stack. What I should do is that fast mode, go use our here. Center, yeah, that's fine. So if you reuse, it'll also say like, hey, if you have a Z stack and a reused image, you don't want the microscope to just jump to wherever that Z stack was taken. So it'll say, hey, this is not a great thing to do. You should actually you should just move it center wherever you are right now. So you always want, in this case, you always want to say yes. That way, it'll just do the Z stack right where we sit right now. It's not going to move the objective up and down. So instead, let's make this Z stack a little bigger, 3 microns or so. Let's see if we actually still see stuff. Should be good. Yeah, that doesn't look too bad. 3 microns, that should be pretty quick. And what I'm gonna do is add like a little time series here. I'm not gonna do this for an hour. Let's do cycles. Say we do 5 cycles or so with no interval. If I then start this experiment, what we'll get now, and we can actually see what it sees while it's acquiring. So this is raw data here. So you can actually see if you hit update. So if you would have a time lapse, of course, this is going too quick to actually see it while it's going. But if you have a slower time lapse, you could actually check these time points in that raw file while it's acquiring, right? Like you see the time points here showing up. So even while the time lapse is going, when you hit the little update button, you can see, oh, my first 3 time points look good, right? Or, oh, it looks like things are starting to drift out of focus. Let's stop, right? So that's what you can do here in that raw file. Like it'll give you an idea of the signal. Now we did this like super, super fast. So we have 5 time points. So you see here the time point slider, and then here you see the Z slider. So this lets you move through Z. You can actually also go here to this little tab, 3D, that'll show the structure in 3D. So all of these tabs here, they're all contextual. So depending on what kind of data you took, right? Like if you took a Z stack, you'll get 3D tabs because it'll let you show what does this look like in 3D. This will just give you like a basic render. You can do ortho view, so you can see the XZ and YZ planes here. You can move this around, so you can move and see what exactly this slice looks like. All of that relates specifically to the data that we have. If we then also have a time lapse, it usually gives you this mean ROI. There you can track intensity over time. Say I just grab like this little area here. Oh, they picked a stupid color. Let's see. Let's do a different one there. So there you can follow intensity over time. That's where it's like seeing if something is bleaching. You can even do this during a time lapse, like click mean ROI and track how everything is changing over time. But of course, this can only show up when there is a time lapse. So all of these here, they're all contextual to your experiment. I always recommend just double checking this info tab too. This is where all the metadata lives. This will tell you too, like lasers that you use, beam splitters, laser power, gains, what detector, right? Oh, we were using the Airy scan, so Airy scan will show up here. So all the metadata is displayed here. There is actually more metadata that it can show here, like all kind of tiny things that are on the microscope. But when you hit that reuse button, it'll copy all of that in here into the experiment, right? Like this won't tell you, oh, you took a tau region in this particular area, but it will be encoded in the experiment. So once you hit reuse, it'll bring in that tau region for your experiment. So that's what that all does here. But yeah, C-stacks, like it'll store all the individual slices. If you want to do like a maximum projection, right? Like collapse all your slices in one go. I always recommend go to that ortho tab. Where is it? Maximum intensity projection here. You actually see a preview here. Then you can say, okay, I want either XY, XZ, YZ. Current view will just make all of these. You can even do one for a full time series. Because in this case we have a time series, but let's just do XY, create. That'll make a new image, collapse the Z-stack in one plane, and then also through time. So we can get them for all the time points. So it's like a quick and dirty way to quickly make that.
Do that a lot.
Okay, that's good. That's good. I'd say that's really the quickest way to do it. You can also find it under the processing tab. So processing tab, I didn't really talk about it that much, but basically that has all post-processing elements in there. So projections, right? Like the one we just did, max projection. You just type projection. So you'll get, I think in this case, it's called orthogonal projection because it gives you multiple options. It's not just a max projection. You can say, okay, same things. I want XY. I want the maximum projection. You can do a minimum projection, average projection, all that stuff. You can even say, oh, I just only want it for particular slices. Obviously here we just have one slice, so it's just going to say one. But if I highlight my actual stack, say like we have 14 slices, so you can say, oh, I want slice 6 to 11, something like that. So you can play around with that in there. Same with the other thing that's pretty common is stitching. Right, stitching function lives only there. So if you have a big tile, this is where you can stitch everything together. And there's a number of other functions that live here. I mean, even area scan processing can be done here as well, but I generally either go through direct processing or the little tab you see at the bottom. So most of the time I don't really do much in here, but the option is always it's always there. So a lot of things, yeah, you can find here. The other thing I use a lot is the subsetting, is where you say you take a big stack, but you only want a certain part and you want to make that into a new file. That's what you can do in image subset. Same with if you say you take 4 positions and you take 4 Z stacks and you want to pull one of those Z stacks also as a separate file, you can say that here or you want a specific position to be subsetted out, or even a region that you just draw. Say I only care about, let's see, this area here. You could say, hey, that ROI right there, cut this piece out and just make that in a separate file. So all of that lives under the subset function. This is nice, especially if you just have like a big chunk of data and you want to work with just like parts of it, but make them a manageable size. So you can subset any way you want right there. But yeah. Anything else?
I remember that in the 780,
Yeah.
maybe in the 882, the order in which you place positions or time series was determining when you play the experiment, which order.
Oh,
Is it
I
Zeiss
see.
here or we're gonna have a phone?
Here, it's not as essential. So as a default, doesn't really matter. So the other thing, I know Zen Black, right, is the version for 780s and 880s. You also have to be careful if you have like multiple things. So selected, right? Like you have to uncheck. Like if you're doing live, you want to make sure that the right track is selected. Here, it doesn't really matter. Like you can have both selected and hit live. It'll just go live to that one that's highlighted. Um, so, and I can say, oh, I want to switch to green now. I just click the green, right? So that's pretty straightforward. That's definitely a lot better than black. Here, the order you see here in this dropdown, as a default, it'll say time, regions, tiles, Z tracks. So that's honestly the one that people want the most, but you can pick a different one if you wanted to. So time, regions, tiles, Z tracks. I always have to think about this for a second, but basically it's doing for every time point, cycling through all the regions, cycling through the tiles, cycling through the Z stacks. It's not going to do one position a Z stack, and then another time for not like oh that Z like do the full time course in one spot and then the full time course to the next spot. That's most typically people don't want to do that, but there are experiments where that could be useful. So those are the orders here. Like if you go to regions time, that's where it'll do that, right? But as a default, time region style Z tracks, like that will be what you want to use. It doesn't really matter what order you click.
Reverting the order between the tiles and the stacks. Might be good.
If you're
Maybe you
doing
want the tiles first and then move to the next position. Right?
so no, it's what it'll do is it'll take the Z stack of the tiles, right? So if you have a 3x3, every tile
Mm.
will have a stack if you have it combined with stacks. Because it'll combine these once they're both checked. If you need it separate, I mean those are just different. Yeah, I don't know if there's a practical situation where you would want to have take a tile and then take a Z stack somewhere else, right? That can be done, but I would use the experiment designer. Most of the time you'll want like a stack for every tile. So what it'll do is it'll go to the first tile, take the stack, go to the next tile, take the stack. It's not going to take full tile and then go down a little bit and then a full tile. It should go like, yeah, I think as a default it'll do stack, next spot, stack, next spot, stack. That should be because also the this also ties to the focus map, right? Because if that center is moving, it would have to if it would do tile, right? It would have to also move to a different plane every time. So it would take a lot more time versus just going to one spot and then going through the Z and then to the next one. So that's that's the default way that solves it. If you are on a tile, I think we have it checked right here. Tile region. You can also control like how it moves through the tile. So as a default, it meanders, which you can see the little arrows here. Goes left to right, right to left, left to right. Combing right, left to right, go back, left to right, and then spiral start in the center and roll out. This is mostly important for like samples that like if samples are not stable, right? Sometimes it's better to just if you're going from the center so that it doesn't like shake as much, or that it doesn't do bigger jumps, right? If you do, for example, that cone, that means the stage moves bigger jumps. But as a default, meander usually works fine. But I've seen it where some samples like spiral worked a little better. But again, very sample dependent. The thing I see people change more is that state speed. So you see here it says through state speed from state control and acceleration from state control. Those are the numbers you see here on the right. So speed is 100%, acceleration is 100%. Sometimes 100% can be too fast, right? Like especially if it's like jumping around. So if you see like, especially at the top of your scan, you see a lot of wiggle. It means that it jumped there and then your sample is still wiggling when it starts the scan. So one way to deal with that is like bringing that speed down. So say you go like 50% or 10%. Because this part of the scan is not a big part of it, right? It's just moving between the position when it's actually scanning. That's usually taking the most time. But this makes it so that your sample doesn't get rocked as much when you're moving around. So it's just good to have that going, or like make sure that you know where this is, and then change it if you see any effect. I think as a default, this will be set to 100, but if you see anything where your sample wobbles or you think it's not as stable, will really help to get like a nice stable stack and no movements at the top of the scan. So yeah. Minimize this one here. Yeah, I think as a basic start, I think that's a good point. Ben, I know everyone's brains are probably getting a little fried. What I recommend too is like when you're starting out, what we see help a lot is that if you go to the system like with someone else too, so that if you're trying to figure something out, that there's someone else that can remember things that you can remember, and the other way around. I think that's always been pretty helpful, especially in the beginning. And then write things down that you run into. So like if you're trying to figure something out, can't find a certain option, or trying to work out a workflow and it doesn't do exactly what you want to do, like write down the things that you've run into and you would like more help with, and then we can collect it and we can make a really targeted follow-up training. And also like let each other know, because if one person runs into something versus someone else, we often see that one person in the lab has like a perfect solution for something, but then the other people just didn't know. So it's good to just know from everyone what they're running into, especially if you're using very similar applications. So that should be good.
Can I ask one?
No, you're out of questions.
I know that.
Long paths, short paths filter.
Yes.
Can you show them again?
Oh yeah. So let's see if we have them here. So for the area scan, that'll be filter based. So you'll see them here in this drop down. So we should put up that poster because that makes it easy. We'll just like, point at the poster. But basically, it'll show this image, right? So when we're looking at the long pass and short pass filters or dual band pass filters, we're looking at these two wheels right here. So light comes from your sample and then goes through one wheel and then the next, and then it hits the detector, right? So you have control over emission on two spots in the beam path when you're going to the area scan. So first wheel is this one right here. So this is the first wheel that the light is going to pass. I'll point out the non-short pass, long pass filters first. There's the plate. Plate lets through everything. Plate, I honestly, the way to remember is it's just a glass plate. Just lets through the light.
So it's SBS because it's not the main beam splitter, it's the
Secondary beam splitter. Yeah, exactly. That's exactly what it is. So if you look at the diagram here, these are the main beam splitters. The main beam splitters, they do the lasers. They reflect the laser light to the sample, make sure that laser light, reflected laser light doesn't go to the detectors. Because you don't want to pick the reflected laser light up, because then you're not going to see your actual sample. You're just going to see a bright reflection. So those are the main beam splitters. There's two of them because there's one separate for 405. And if you would have two photon, that's where two photon wavelengths would come in. So that's called invis because they're like outside of the visible spectrum where all the visible lines come in on that other wheel. So that's why you see two MBS options. But the SBSs this is the secondary beam splitter. This one is just a filter called like a filter wheel in front of the area scan. It's not a beam splitter. It's just purely filter in this case. So if we then look here at this drop down, so plate lets through everything. You can kind of see it, right? Like it's just a bar. Mirror, you can imagine that a lot better when you see this, right? Like if you have a mirror here, it mirrors all the light and sends it into the confocal, right? So if you have the mirror in place, nothing will actually go to the area scan. So generally, if you're doing area scan, you're not going to pick mirror there, right? So this is only there because if you're using confocal, that's what goes into place. Then short pass 505 basically only lets everything through below 505 nanometers. So that's your DAPI and your CFP in this case, anything like below, even below your GFPs, is in that range. Long pass 525. So you can see also when I have this GFP graph here, it shows what that filter is going to let through. So all of these positions, like they have a range of what they can let through. Generally, on best signal on the air scan, it'll pick a filter that makes this, like tries to not get the tail too long, especially on the lower wavelength fluorophores. But you can play around with this too. Like if you want to get a little more signal, for example, in this, you can try out the plate. It just means that if you have plate and this laser line, say it activates some other fluorophore, that you wouldn't be able to distinguish, right? Like it would bleed through. So if you want to block off the reds, I mean, this one would block off like the red emission right here. So that's one thing to play around with. Because there's two filter wheels, you could do one here and then even narrow this down. Here, see, like this would actually cut to like a very specific wavelength. So if you want a really narrow emission spectrum, it is possible with combinations of filters. I'd say generally that's only specific situations where you have two fluorophores very close to each other, and you need to send them to the air scan, right? So that's good to keep in mind that those options are there. Like you can use both to make a combination of two filters to cut things down. Because the second wheel, so this is that wheel right in front of the air scan, it'll have a lot of dual bandpass, right? You see like two windows of emission that come through. So for example, here, this would be your DAPI GFP combination. If you have this filter in place, you could actually do line scanning with a DAPI and a green. I still wouldn't recommend it as much because DAPI has such a long tail, it'll show up in here. But that option is there. I'd say the more common one that people use is that red-green. So this one will do your green here, your red there, and then you can switch lasers between the two. So you can have a filter in place, so relatively clean emission, without switching any hardware. You just switch lasers. So if you have a green-red combination and you want to send for the air scan, this is a really good option for the filters. And here you could still say, oh, I just want the green. I wanna get rid of that red here. So then you could go to the other filter wheel, that SBS wheel, and now even though you use the red-green filter, it cuts away all the red. Now you purely have the green. So combinations here are really, really nice if you want to keep it very narrow.
And when you're changing the filters, it will automatically assign the right MBS.
No, this is unrelated to the MBS. So in this case, MBS is related to laser lines.
I have to make sure that they are.
Yeah, that they are well. So it generally will automatically do this if you set up Smart Setup, it'll automatically pick MBSs that match. The only moment you have to double check this is when you are manually switching between lasers. If I'm gonna say, oh, I want to throw in this red here, actually it doesn't matter because it already have the right MBS for it. Let's give it something harder to do. 514. So you see, this is a weird combination, these two, because now it doesn't have a direct filter for or like MBS for both of these, right? Like there's no combo that's like 445, 514. Generally, I'm not gonna want to do those two at the same time because they're very close to each other. Like most like doesn't matter what filter you put in, you're gonna get crosstalk if you do this kind of experiment. But you can see already now it does that weird TR80 or T80R20. I don't want that. So this is where you want to check that MBS, like, oh, I don't want to activate this laser. I mean, you could totally unactivate it, then say 514. It should pick a nice one. We can see what it picked here. Yeah, one that just has a 514. So generally, when picking a laser, it will auto-populate this, but just make sure that there's not like, right? Like if I just add this one here, let's see if it's smart enough. Yeah, see, so now it keeps this one in here. I don't want that one for my green. So if you are manually switching lasers here, keep an eye on this. I think that's the main rule here. If you did Smart Setup, it's going to pick the right thing here. You don't really have to worry about it. Only when you're manually changing things here, but most of the time you're going to go through smart setup anyways. So that won't really be a point. But yeah, that's a good question too, because if I have these two tracks right now, they will have the same MBS, right? Like this 561. Actually, let's see what it picked. Yeah, the same MBS. So there's not a change between the different tracks. But if you have, say, like a DAPI in there, I would actually change this one also to DAPI for the green and the red, just so that it doesn't have to do that change every time. One thing I should point out here too, and actually let's just look at Z-stack alone. If you do a Z-stack, you see how there's this dropdown that says all tracks per slice. What that means is it's going to do every color for every slice. If you are in best signal mode, it's going to do green, full frame, change the hardware. Red, full frame, change the hardware. Next slice, green. So a lot of hardware movement for every individual slice. To minimize that, there is that full Z-stack per track option. If you're doing best signal, I would go for full Z-stack per track. Then it'll do green, whole track, or whole Z-stack, then switch the hardware, then red for the whole Z-stack. So it only has to change the hardware 2 times, right? Instead of, in this case, 16 times 2, right? So it's a lot less wear and tear on the internal components. Of course, if you have like a live sample on there, something that's going to move, you don't really want to do that full Z-stack per track as much, because you'll see like you'll take all the green, then it'll move back, and you'll see that your red channel is a bit shifted. So there, all tracks per slice is nicer. If you then still want to minimize the amount of hardware movement, I would say go for a line mode experiment. Line is good for things that are moving because it'll do all of them at the same time. It doesn't move any hardware. It's going to be a lot faster. So if you can get away with doing a line mode experiment, I would opt for that. I would opt for that route. Because then you don't have to worry about this drop down at all. Like if you are in line mode and you do all tracks per slice, it doesn't really matter. It's just going to collect red and green almost simultaneous because it just switches the lasers on and off. Yeah.
When you click that one, it changes to frame.
When I did all tracks per slice, it switched to
You
frame.
can do a line.
So I guess it is on a, oh, I see. Yeah, it's because probably like the filters that we put in. I wouldn't want to do line mode here anyways, because, well, I would do it differently here. Let's just do a plate. I mean, you can do, it should be possible. So all tracks per slice, line, it'll probably give, yeah, that's fine. It shouldn't block it at least. Yeah, no, it's fine. It's mostly switching back because I'm changing some parameters. Right? Usually if I'm changing something in one track versus the other, and it assumes like, oh, you only want this for this track, it'll swap back to a frame mode because it knows that, oh, you're modifying these parameters, so it sounds like you want to do different parameters between the 2 tracks, which is often the case, right? So it is good to keep an eye on that because it'll try to help you, but of course, if you're trying to adjust something to make it like fast with line mode, you want to make sure it keeps it modified like that. I mean, this experiment line with this filter with this particular MBS should be totally fine. Yeah, because it can let through both. It's always good to check. This comes through on both sides, so it's totally fine.
So there are multiple combinations. So as you said, if we choose the full Z-stack, and
Mhm.
better do with.
So full Z-stack per track, honestly, you want to do that in
Z-stack.
frame mode.
Right,
Yeah.
but also here you want to do Z.
So here, I mean, there's a couple extra options when we have
Right, yeah.
Z-stack selected.
Combination.
Generally, I don't pick these things here. I pick like smart setup and pick my settings there. Maybe I'll pick my drop down here. Here, so this will do exactly the same. See, if I pick Z-stack here, it'll auto change this here. It just means that it'll take the whole Z-stack with one hardware setting, then go to the next color and take the whole Z-stack with the next hardware setting. This is more efficient on the internal like motors and mechanical components. So in general, yeah, for the longevity of the system, it's better for those types of experiments. But there are ways around it. If you're using line mode, this doesn't really matter. So that's really the choice here. But I generally wouldn't change this as much here, because especially going from here to line, it's going to override like multiple settings. So I wouldn't do that, especially starting out with the system. Once you done like, yeah, a lot of experiments and you mess with a lot of the parameters and you figure out like what is good for your samples, that's where I would say like, okay, now you want to change things to manual. You get to a point where you can outsmart smart setup, right? I think that's really the point where you're like, oh, smart setup, you picked something dumb. Like this is not good for my sample. When you're at that point, that's where you can actually completely ignore smart setup and do everything manually here and here, right? But as a starting point, I wouldn't start doing it like that. I would first start with smart setup, see what it suggests, work from there. If you find ways to make it more efficient, add those manually, and then build from there. Yeah. Yeah, no, that came with the system, I guess.
So we do have class 4 and class 3B.
I guess
Laser,
it's,
okay.
yeah.
Yeah, so we had the laser safety training where if you have over. Yeah, that's what we had.
I believe it was 3B.
3D.
What's 3B? Which one?
I guess it depends on if there's like two photon on there or not.
Yeah.
Well, are you like required to put something on the door or like?
Yeah, probably, and also like laser safety training, usually has that too. It depends on the class of your laser.
Oh, I
Yeah.
see, I see.
Yeah.
Yeah, because here, I mean, you have to work pretty hard to like give
You
yourself
have to
basic
work
on this system.
tremendously hard.
Exactly.
You have to be doing a lot of.
Yes.
Yeah.
Because you saw it, right? Like, well, this thing is,
Trivial.
oh, it won't even shoot the
No, no,
laser out.
Yeah, it's
Like, yeah, you have to like.
laser kill, yeah.
This is specific training.
Yeah,
Like, if that's what you're, the training is less.
Yeah.
Yeah, so this should be okay. Like these are all, that's also nice. If you're used to the older systems, like this actually just uses like diode lasers, like they're all like solid state lasers. So it's not as like important to like when you shut everything down that you have to like leave the fan running. Here you just like power it down. There's no like, oh, turn the key, wait 20 minutes, like all that crap. Like that's not at all the case here. So also if say there's something that crashes, right? Like say that either like the software just like gets hung up on something and it doesn't come back anymore and you have to reboot. It's also just a matter of like closing, like forcing the software to close, and you can power down the system fully, and then you just wait a minute and just like repower it back up. It's not like you have to keep it on or off for like a certain amount of time before you can flip that switch.
And so between users, do you suggest like how much time between users would you suggest to turn it off, turn it back on? I mean, no, it's not a big deal, but like, you know.
Because the biggest thing is actually going to be like the warm up of the system and then cooling down. So ideally, if there's someone within like half an hour, I would honestly leave it on. Even an hour or so, I would probably leave it on. Once it goes hours, right? You can turn it on. Because you'll see if the system is like warmed up. And then someone turns it off and it starts cooling down and then gets back to warming up, you'll get, especially right as you start imaging, right at the start, you'll get some projection. So just leave it on in that case.
So the laser have no warm up. I remember the old system, they have a little green button.
So you will see,
light.
usually when you start, like right at the start, you'll see them here warming up a little bit, but it's very short. So they'll show up as red. You can actually, while it's red, like if you accidentally hit live, it will still scan. You'll just see like there will be like a little bit of a fluctuation. So just wait until that red is gone. But again, that doesn't take.
There's no
very
physical
long.
light. You say, okay, the laser's red.
Yeah, there's
so
no-
they standby mode or anything.
No.
Okay.
And then the Zeiss system, you have to go in and save each image one by one. They're not automatic.
So we have the autosave,
Right?
right?
Or you have to
If you don't have the autosave on, it'll ask you. So
Oh,
if it used to be on the older systems, like if you messed up and like didn't save and like
yeah.
closed, it will be gone.
Okay.
Or if you did live and it would
Yeah,
override
right.
another one.
Yeah.
Doesn't really do that anymore. Like it'll once you hit start experiment, that thing
It'll
is
make a new tab.
yeah, it'll be generated in a temp folder too.
Okay.
So you'll find it in a temporary folder
Oh,
too. So you can actually see in there everything that's loaded here. Even if I haven't saved it yet, this is going to be loaded in a temp folder. But I do recommend like autosave is the easiest. You just give it a name once and then it'll list and then it'll spam all those into the same folder.
Okay.
So that's really nice.
Do we need to clean up the temp folder periodically?
No, once you close down the software fully,
Oh, they won't.
it'll clear it out. That's why when you close down the software, if I do file quit now, say I do exit here. See, I get this.
Okay.
So this is what it'll do. Like it'll say, hey, these are the things that are not saved. It even says, remember how we put in some stage marks, right? So those can also be saved. So it'll ask you like, oh, do you want to save these? Because you can save a list of those marks and you could actually import them as positions, right? So those things are that's what happens. That's what happens right now. So that's a big improvement. But yeah, back when I was on the 700, we didn't have that. I definitely lost some data that way.
You're like, no.
Yeah, oh, that was the best image.
Of course, yeah.
So yeah, that's how that works. I mean, you can also like here. Oh, I got rid of it now. So yeah, you could. So if you see the images here on the right side, so then they'll be listed here. You can even, I mean, I don't really do that, but you can give them ratings, that kind of stuff. Like, oh, this is a 5-star image, that kind of option. It's good for like coming back to something later. So like if you open 10 images and you're like, oh, which one was like a really nice one, that'll be marked. But yeah, pretty convenient. But yeah, I didn't really talk about Zen Connect, but that's honestly more of a advanced feature. Basically, what that does is it lets you also create a project folder and then connect data to each other. Say you do a 10x overview scan and then go to a higher Mac image. It'll map things onto each other in a separate project file. So kind of like that map that we created, it'll auto save that into a project file. You can even image something, take it off the microscope, and then bring it back, and then open that same file project, and then synchronize the things that you're imaging in your second session to the things you imaged before. You could even take, say, imaging data that's not from the Zeiss, even like anything with pixels, right? Like take an image with your phone, take a picture with your phone of your slide box, and then import it in there, and then you can overlay your microscopy data like on the slide box, like which slide that was. So it's a nice way to tie data together. I mean, I don't have time to go over full Zen Connect project because that's a separate chapter. But it's fun to play around with, just to look into it. I think there's a video in the portal as well that shows how to do it. I added the portal. This is something else. Here to the favorites. So here, I mean, this is Edge. You can put Chrome on there too if you want. But right there, that Zeiss portal, if you go there, it actually, I put in the link that directly goes to the video section. So that has all the basically short versions of everything we talked about today, like how to align the area scan, how to set up a Z stack, all that stuff you can find in there. So all you need is like a free account. Did you actually end up making an account? Good, perfect. I would honestly say everyone just use your account because that way, like it's mostly just for you to have a login to get to the videos. I mean, you can do other stuff in there as well. Like you can put in service tickets, that kind of stuff. But one account or maybe one per lab should be enough because you can tie it to this microscope too, so that when you put in a service account, it's like or service request that it's tied to this system, and then we have a record. But I think most of the time people use it to go to the videos and get like tutorial access to the tutorial videos. So yeah, that'll be right here. So yeah, I think that's pretty much it.
The shutdown is just close down the software, close down the computer,
Yeah.
and then hit the switch, the main switch.
Yeah, so it's all like reverse order. So we're just gonna exit here. One important thing, when you shut down, there will be this little message. It'll be on the screen pretty short. It just says, Zen is shutting down. Do not switch off the system hardware until this message disappears. So while the software is shutting down, there's still like communication between the software and the hardware. So you don't want to power off until the message is gone. Now the message is gone, so we can just turn this off right here. That's all really that we take into account right there. So yeah, that's pretty much it. Share.